Hello. How you guys doing? Welcome, welcome. How was your week? Sorry about Friday. Good afternoon, Bridgewater. And the guy Doru. Welcome. Welcome, welcome. Sorry about Friday. Something came up that I went to. Some family stuff. Nothing bad. Someone graduated somewhere. So that's why I wasn't on Friday. Because I was hanging out with some family. But welcome. How you guys doing? Hopefully it was a good week for you all. I've got some grievances about work later that I'll probably get into, but not now. But yeah, so today I'm going to continue onwards with this audio stuff. Last I left off, I was starting to feel pretty good about where the direction I was going. A lot of it's a lot easier to follow than what I was doing before, which is a good thing, a very good thing. I don't think we've actually tried running it yet, though. I need to find out where I left off, exactly where I left off. But I think we're getting close to somewhere that might sound somewhat decent. I think I need, from what I remember anyway, the 2 pulse channels should more or less be implemented. More or less. But the triangle and noise channels, I think, need some... not coercing. Like the... God, I remember part of it anyway now. These buffers here. I need to... what's it? Not rectify. What's the word I'm looking for? I don't know. I need to make those make sense, if that makes any sense. I think it's going to explode for a run. Probably not. Probably not. It might not even assemble. I don't think I tried that before yet. Make. It doesn't even assemble. All right. That's not really surprising. Jojo, how you doing? Also, I'm not sure if you noticed, but I am back in the terminal I used to be in. Because I figured out what the issue was with Vim. It's a setting. It's just a setting. It's just a setting in Vim. all the stuff up here, by the way, is me trying to figure out getting that other terminal. URXVT, I think it was. Figure out getting that one like working correctly. I got it to a decent point, but like the fonts were all wrong for some reason. I don't know why. And I couldn't fix. It didn't want to like I don't know, keep the font stuff like the bold this bold text. The kerning was all off, so all the letters were squished together. I don't know why. But I don't have to worry about that anymore because I fixed it. I fixed it in this terminal, so we're all good now. It's always just a setting. I never would have found that setting, by the way, because I never would have stumbled upon it on my own. That's not the one I want. vimrc, not the bash. Dot vimrc, like there. There's our error. Set t underscore ut. What the fuck? It's background drawing stuff. It's background drawing stuff. Like, don't erase the background. Just draw. It's fine. That's what that is. That's what that is. It's don't erase background. I don't know, something about transparency, I guess. But that fixed it, so I don't have to worry about it anymore. Anyway, unexpected channel garbage catchers, no such scope, channel pointers. Hold up, that's one of the things that I should have, isn't it? Engine RAM offset is already defined. Let's start there. RAM, that's 13039. Offset. Whoop, 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 whoop. Oh, yep, it is. Okay. I need to make sure that I'm not overlapping with something then. Symbol dot size is already defined. 194 constant expected 1994. Oh, go to hell. It's right there. Shut up. Is that why that didn't work? No. What is this? Constant expression expect. What the hell do you mean? Hello, welcome. How you doing? It's a constant. What are you talking about? Huh? What happened? Where did I go? 194. Go over there. Oh, I hit. That's what I hit. This one right here. Why don't you like this? Why? Pulse A instrument. Pulse B instrument. Where the hell are these? Are these? Oh. Well, that's probably why. Did I? Huh? Where'd they go? Oh, because those are part of the state now. They're part of that because it's instrument on the. Okay, I see why now. I see. I don't want that. Okay. All right. Probably another one on 196. Current channel instrument length. Channel instruments. Yep. Same thing. Okay. Now then, what's this one? No such scope channel pointers. That's the wrong. Okay. Okay. 187. Where is that being used? Channel point. Pulsate pointers. Huh? Frames. Channel state struct. That's what I... Is this another one that I brought in too? Okay. Oops. Probably. Hex digit expected 6682. Channel stayed 915, 915. That's close enough. Channel state weight. State structure. Like that. 10, 40, 40 stats. Come on, 46. There it is. I did it again. What? Why do I keep doing that? 1171. Single channel length. This is just wrong now, isn't it? That's why I needed... Wait. Why did I need that? Hang on. Can I get like a size of for the structure? Can I just do that? That's a instrument struct, right? Size of. That. Unknown similar scope. Okay. Why? Instrument struct. It's in the same... We're in the same scope, right? No, we're not. It's out. Why do I have it outside the scope? Why? Why would I have that outside the scope? That doesn't make any sense. Seven one. Okay, 11771. This is the one I saw before. Yep. This I don't actually care about anymore because I just handle that with my macro now. What is all this now? What the fuck is all this? Song meta undefined. Symbol expanded from here. Huh? main. Okay, let's hop over to main real quick. 223. Oh, the engine in it. I need to rework that, don't I? Pointer to song meta in pointer A. Okay, that's channel state, start your flags. Clear buffers. Where is this macro? Oh, yeah, okay, so none of these are good anymore, because that's not a thing anymore. Because instead, so, okay. Engine RAM, because that's now the buffer stuff, right? Buffer, where are you? Channel start, fix me is okay. Buffer, here we go. Clear buffers. Wait a minute. Pulse sweep. What the hell is that? Let me go ahead and Control N on that. Bring that over here. Over here. Reference. APU. Not the specs. Well, yeah. Envelope and sweep. Oh, that was just this stuff. Negate. Why am I setting the negate flag? What the hell? Negate. What does that do? Huh? It's just the duty cycle stuff? Huh? The behavior of the two pulse channels differs only in the effect of the negate mode in their of their sweep. What? Sweep. Up or down. Negate flag. Add to period sweeping toward the lower frequencies. Subtract from period sweeping toward the higher frequencies. Oh, so that's just for sweep, which I'm not even using, so I can ignore that. What the hell? Yeah, no. Instead, we're how many times is this used? Sound init and sound process. Let's make that a routine, actually, instead of one of those. Layer buffers. Also, we're gonna rename this to init. Because I don't need to sound engine, sound init. No, just sound engine init. Just do that. Okay, so clear buffers. Yes. So we're gonna loop through a bunch of these. Basic. Well, do I need a loop? Let's write it as not a loop first. How about that? And then I'll loop it like after I figure out the iteration. Load up. Load up the low byte of pulse A buffer. Store that into Which pointer do I want to use? I don't think it really matters, so I'll just use pointer A. Pointer A plus 0. Same thing with the high byte plus 1. Let's use X there, because why not? Load A 0. Load Y. Channel buffer. It's literally right there. Okay, I need to actually search for that. Oh my god. Ready. Store A. Pointer A at Y. I'm not gonna use increment here. I'm gonna use each one individually just so it's a bit easier to read. And a bit more deliberate what I'm doing, I guess. Yeah. Timer high, duty vol, and the sweep. Ready. Timer low. Timer high. What does it do again? Right. Duty vol and sweep. Sweep. And this, so I can. These are so I can know what the magic numbers are in this assembly. Okay. Load Y 0. Loop. Transfer Y to A. No. Store Y. Temp. What do I have for temp? Temp A. I'll use temp A. Why not? As a good programmer told me, magic numbers should stay magic and mystical. Load A temp A. ASL A. Transfer A to. What? Wait a minute. Hey, that'll work. No. No, I can't do that. Let's do it this way instead. I don't know why I did that, but JSR clear. Pulse A. Pulse B. Pulse B. Triangle. And for the last one, I don't need to do the JSR. This one is just going to be noise. Fantastic. That should work. I think I've seen this technique kind of used. I'm pretty sure I've seen this technique used elsewhere. Probably in StudyBox stuff, where it calls to a routine, calls to a subroutine, but then just falls through that subroutine at the end, and that last RTS, instead of going back into itself, it just gets out of there. Yeah, that should work though. And JSR to clear buffers. Oops, no, clear buffers. Good. So where's our other clear buffers? There it is. JSR to clear buffers. Okay. These guys. These I don't need anymore, right? Yeah, I don't need this one. How about this one? Nope. Good. 'Cause I think I removed the need for those last stream. Yeah, so I don't need any of that crap anymore. Okay. Triangle point. Did I just clear that crap? Noise period undefined. 1, 3, 5, 5, 5, 5. Metaforte? How you doing? Hi, is this assembly language coding? Yes, it is. Welcome. Welcome, welcome. Where am I? What is this? Noise period. Noise period undefined. Right. Okay, what the huh? Is this where I what noise we're trying to ready? Whole speed 2D. Where the hell is this even? I didn't do any of this. I didn't, because this is the buffer writing stuff. Okay. All right. I didn't actually redo this and any of it. We're gonna do something similar. With this here, it's just gonna be write buffers. Yank. Right. So now, instead of storing that, or I'm gonna load that there, and this, we're gonna start storing this stuff. This one. For this one, if this is equal, go over here. Nope. We ain't ready yet. Not ready. Okay. Load A. Okay. Timer low. Let's write these in numerical order, I guess. 0, 1, 2, and 3. Right? Yeah. And I might actually swap around the bytes in the buffer, just to match up to this. So I'm gonna move this over here so I can see while I'm typing. Because that's gonna be duty first, duty volume. Store that into. Do I unused. Does it matter if I write to an unused? I'm going to assume no, and I'll just write it anyway. Yeah. Store that to... I need an offset. for these. Well, 4,000 at X. X is going to have to be the start offset for this stuff. Load X, 0. Four times 1. 4 times 0. 2 and 3. Increment X. Okay. That should work, right? Except timer low. That one. Nope. The sweep is second. That's what goes there. And then it's low high. All right. That should work. Probably. No. Engine flags, engine flag buffer ready. No, I don't think I care about this anymore. Because we're gonna look at all the buffers, not just if they're all ready to do the thing. No, if each buffer individually is ready, we'll write that buffer. Yeah. Oh, and we'll need to turn off the ready as well. Branch equal, okay. Load a 0. Store a, clear the ready flag. Okay, that's that one. Yeah. Then I can just not worry about it. Okay. Achilles pointers. Where is this? Where now? Where? Huh? CH running on the oh god. 1, 2, 9, 5. Where is this used? Halt. Oh. Stop the currently running instrument for the current channel. To write this at the instrument implemented. No, for this, I think I just want to clear out that instrument then, yeah? Well, hang on. Do I have a running on the state structure? Wait, read offset, current frame length, tick rate, last note, ready. I don't have a running. Because that's in the instrument struct. Okay. How do I actually, when I jump into these things, do I have, what what information do I have? Get instrument point from parent debug. Do command buffer. Okay. No. Command lookup. Pointer channel. Okay, I've got a pointer to the channel. Wait. Well, yeah, okay. Blocky Headman, how you doing? Object-oriented assembly. How so? With structures and pointers and things and offsets into said structures. On the NES, I've got 4 audio channels to work with, right? To pulse, a triangle, and a noise. The 2 pulse are more or less identical. I think there's some minor differences between them. But for all the instrument stuff, all that is universal, kind of, right? Things like volume and arpeggio and that kind of crap, right? So I've got structures of pointers and lists of pointers and all that kind of crap. So in order to, good example here. So in order to deal with all these different structures that are basically the same, but duplicated, right? I don't want to rewrite a bunch of functions to be like, oh, this function is just for the pulse A channel, and this function is just for the pulse B channel, and no, none of that. So this clear buffers is actually a decent example of that. It's very simple, right? I've got some data that I need to write to the sound hardware. Those are stored in 4 bytes. Or those are written to 4 bytes, 1 for each channel, right? We're ignoring the DMC, by the way. So these guys right here. So from hex 4000 to hex 4F. But each of these, that's 4 bytes. The 2 pulse channels are identical in this sense, right? Duty volume and a bunch of other crap, and then some sweep stuff. We're not doing any of that. And then the actual note in the 2 timer fields. The other channels also used for, well, 3 technically, one's unused. We're writing it anyway, it doesn't really matter. And the noise is, again, 3 and 1 unused. But I don't need to do any like specific crap just for the pulses versus the noises, right? In regards to writing the buffer. It's all the same across all 4 channels. And so I don't want to have like the first pulse and then write the second pulse and then write the triangle. I don't want to have separate routines for all that. So what I do is I just load up a pointer to that buffer, and then I jump to a little routine that all it does is using an offset into that structure, right? I load that up. Or rather, I load up 0, but then I look at that offset, and then I store that 0 there, right? Same thing with that's for clearing. For writing the buffers, same idea. Loading up the value at that offset in that structure, right? Given the pointer. So pointer A is the start of that buffer, right? And Y is that. The Y register is that specific field in that structure. So I'm looking that up at an offset. And I'm storing it at an offset too. Don't worry about that. But this means I can use this one block of code right here for all 4 channels. And I don't have to worry about doing anything specific. So the whole object-oriented thing is I'm throwing a pointer at it, which is a pointer to a structure. And that's basically what objects are. Structures with methods attached to them, right? So this here could be, well, I guess this right here, this CLR, could really be like buffer dot clear, right? If we're looking at a newer language, right, where buffer pulse A equals like a new buffer. One of these kind of things, right? something like that, kind of. Last time I wrote an assembly was during my college. It's almost 10 years now. Almost forgot assembly. Async? No, this is async. The asynchronous doesn't exist on this system. Doesn't exist on this system. But yeah, so that's basically what that is over here. And to a similar extent, a more complicated example is how I'm processing each of the actual individual channels. So if I go over to Family Tracker, give me a second. Let me load up one of these songs here real quick. Not that button. Oh. I actually found the original file. I wasn't expecting that. Cool. Thank you for the file. Appreciate that. So this is a list of basically all the notes and things that happen for each channel. I've got pulse 1, I've got pulse 2, triangle, noise, and we're ignoring the last one. The DPCM. But all these, they have a note, they've got a... I forget what those are. What the hell are those? No. Interface, probably in here. Pattern editor. Ah, okay, there you go. Note and octave. C, the note C, octave 1, note F, octave 3, right? Instrument 15, instrument 1, so on and so forth, 5 over here, 2 over there. The volume, which isn't, I don't think, used in this stuff here, because that's actually part of the instrument, is the volume. And the effect and parameter, I don't think we're doing it. I don't think I have any of the effects in any of these, other than like this kind of stuff right here, which I don't remember what is. What is D? Effect list. Oh, this stuff. Skip. Oh, God. Did I ever... Huh? Huh. I'll have to figure that out, because that's going to be an interesting one. Yeah. But anyway. So I've got a bunch of different commands, essentially. Think of it like a weird MIDI. Right? But the commands for each of the channels are the same, just, you know, applied to a different channel, right? So I have 4 objects, really, for each channel, the state of that channel. And then when I'm reading the data, I apply that command to that channel, right? So up here somewhere, process channel. There, that's better. So when I'm going to process the channels, I load up the pointers I need. So the state, which is the channel right there, and its buffer, right? Where the data is, where the data is going, kind of, right? And then I jump to the channel. This here is the channel ID that I do need for some things, because depending on what type of channel it is, I process commands a little bit differently. So that's all I really need for that, right? Yeah. So then I go down to process channel, and this actually reads in the note data and does a thing with that note data, and it changes all of the values it needs to in the object, right? So yeah, you'll see this a lot now. The load Y and then a long name for something, right? So this is the structure I'm looking in. and then this is the field in that structure. Now this is loading up the offset, so I can use that as a or in a load with a pointer, right? Pointer offset. That's what that is. Yeah. Anyway, so the instrument crap. Skip argument on 0. Oh, yeah, okay, well. Go to order. Do I have that implemented somewhere? Huh, alright. I guess I do. See, as you can see, a lot of this stuff is not implemented. But FN instrument, because this is like loading up an instrument, right? That doesn't exist anymore. That doesn't exist anymore. Any of the ch underscore stuff, I don't think exists anymore. Yeah. So any of the ch underscore stuff is old code that I need to break out. This old code, by the way, was a nightmare of macro stuff. Which is why I'm doing the object route this time around. Because before I would have each channel would have its own like hard coded name, right? Or each value for each channel. Vars, yeah. These were all of the automatically generated variables for everything, right? So Pulse had all those. Pulse underscore volume underscore loop. Pulse arpeggio loop. Wait a minute. Pulse pitch loop. You see how they're all repeated, right? They're all the same friggin' thing, just for a different, like, a different property of that instrument. This is all instrument crap, right? Arpeggio, that's an instrument macro, right? But all the different macro types or instrument macro types have the same properties, right? But I was still generating one for each of these stupid things, right? Which meant that I had a few macros that read the computed name, right? Read the variable there, and then took that value and dropped it into like a local working variable instead that I would then copy back after I did the thing, which sounds like it works, but it didn't. Not only did it not work, it made everything so confusing and next to impossible to actually step through and debug. Because spoilers, like, it broke, and I had to try and figure out what was going wrong with the sound engine, only to confuse the daylights out of myself. Because it was using all these computed values everywhere. Values that were computed at assemble time. Actually, what the fuck? What was that? Huh? Oh no. Oh boy. Quit out of that, quit out of that, quit out of that. Well, I screwed that up. That's cool. Anyway, get diff. This guy. Okay. So, I've already removed them, but if I look at the diff, I can show you what they look like. Right there. This kind of crap. So I would load the process vars, right? Load A, make an ident, concatenate the channel name, which is the argument to the macro. Concatenate that with state underscore wait. I'm gonna put that in ch wait. Do the same thing with read offset. I'm gonna put that in offset. Do the same thing with state tick. Put that in tick. right? And then when I was done doing the processing of stuff, I'd save it back. Save process bars. Same thing, other direction. And this is so ungodly error prone. There are a few times where I didn't save or load something correctly, right? Like I would load it, but if I'd forget to save it after I modified it and wonder why it didn't work. Or I'd save it without even loading the damn thing. Or I did. So there's a lot of that. And I got to the point where I confused myself so much that I didn't want to work on it anymore. So I haven't really touched this code in like 2 years. Or rather, I started touching it again like 2 weeks ago. So yeah, we are trying again to fix this code, number one, and undo all the stupid crap I was doing. Because there's a lot of it. There's a lot of it. So much of it. Yeah. Store pointer D. Increment offset. What? Huh? Stored channel running. Load 0. Just store that in the offset. When instead I should just be using like, you know, the actual value. Like where it belongs, you know? Yeah. Oh god, and here's even more another example of it too. Where did I have that? Right buffers here. Where I've got code specifically for, oh, this is the Pulse A code right here. All right, let's write the Pulse A stuff. Okay, we're done with Pulse A. Now we're gonna move on to Pulse B. It's the same thing, but we're using different variables, so we gotta do it again. Triangle, same thing, but we're using different variables, so I gotta do it again. Say instead of doing that, I just do it insane. Sure, this may run a tad bit slower, take a few more cycles to actually run, but this isn't really time critical code. The timing critical code. So I don't really have to worry about it too much, you know? Thank you for the follow. Appreciate that. We're actually going to just get rid of that. But I have to spend a lot of time getting rid of all this kind of crap. Like, CH running, that's not a thing anymore. That's part of the instrument. This one right here, CH running. Epic Ninja Elephant, how you doing? Happy Sunday. Sorry, you're like, yeah, you're not that late. I just started. You're fine. You're fine. I'm just getting started. Welcome, by the way. How you doing? How you doing? Okay, so what do I have available to me? The channel pointer. The pointer buffer. Okay. Do I have the instrument pointer somewhere? Pointer frame. No, that's the actual data stuff. Frame list, channel structure. Did I break out the instrument? Set all instrument macros running to number 1. Reset macros to offset 0. Okay. Let me make this a little bit better here. And get myself the pointer to that instrument instead. This is what I want to use. Pointer instrument. All right. So we're going to come up here. buffer stuff. No, let's up here somewhere. Point of frame. Read the data. Check for weight. If not zero, we're gonna return. Okay, get from. Okay, so up here, get pointer to instrument. So that channel state structure. Load up pointer channel plus 0. Clear carry. So we're going to take the pointer to the channel and add the offset of the instrument data. This is an embedded struct. So that's not another pointer. That's another struct that's concatenated on, essentially, right? So we just basically want to add the offset to that field, and then we have got a pointer to the actual instrument structure, basically, right? To that embedded field. So we're gonna load that. We're gonna add carry. That and instrument, and store that into pointer instrument. Excuse me. Then we're going to load up the high byte of that, add carry 0, and store that into the high byte. So now I've got a pointer to the instrument as well. So now down here, let's volume. Oh, yeah. Let's dereference one of those. Instrument. So let's take this up a little bit. Make it a little bit easier to read. Do the same thing here. We're still doing, pointer crap. So this won't take any longer or shorter to happen, but it's gonna be easier to read. Now I could do it. I could do it one more. But I don't think that's really necessary. Because again, the volume, arpeggio, pitch, duty, and high pitch are all the same structure. But I'm only changing one value in each of them, so it doesn't make much sense to dereference that one more. All right. We're gonna skip that one. All right, instrument, pointer frame, instrument ID. What? Huh? Okay, that's gonna be a temporary variable there. What the fuck is this? Res 2. What the? Huh? What the? Why is that? Just so I can use X and Y and so I can use 2 pointers at once? Is that what that is? That's not even... That was... Nope. All right. Instrument ID. No. ASLA. Index to offset. Transfer that to Y. Instrument list. This. Okay. That's this list right here. So we're looking into this list. That guy. Oh, okay. That's... Ooh, I'm using that specific pointer somewhere else. That's why that pointer exists. Okay. All right, we're going to use a different pointer for this. Or rather, we're going to name it something different. Pointer, instrument. The channel instrument. Put it on here. Okay, because this one is to the instrument data, not the state. So the point of macro. Yeah, that's fine. Load X, channel ID. Multiply instrument length. Oh, God. Oh, nope. Okay. Ew. No. Okay, so this, we've actually got some data structures now that I can use for this. Load Y, data macro. Uh-oh. Data instrument. Wait. Hang on. Load macros. Volume. Wait, I'm just... Oh, Jesus Christ. Okay, we're not gonna bother with that. We're gonna rewrite it from the ground up. Because this is more of that code that's like, you know, copy pasted. Doubling channel like that. I need to verify this. I think it's right, but I need to verify. Okay, so I need to load up all of the macros. Pointer macro. Pointer macro is going to... Okay. Okay. load up. Pointer instrument is going to, not that, it's the data instrument, this guy here. Okay, load up, data, instrument, volume, in Y. Thank you for the files, appreciate that. How you guys doing? Load A. No. Those are all IDs. Jamaica, how you doing? Welcome. Those aren't pointers. Those are IDs. So I need to dereference those dereference those IDs. I need to look them up in a list, get that pointer, and oh Jesus. Okay. This will be fun. Spent some time watching the Xbox showcase. I didn't even know that was a thing, did I? Okay. So I've got this is a pointer to, you can't really see it very well, but this right here. That's what that's a pointer to. Which is one of these. So it could be like something like this, right? So I need to load up the volume, and then clear carry, add carry, pointer instrument. No, it's not. God damn it. Load Y. Load A. Pointer instrument at Y. Okay. That's the ID. ASLA. Or index to offset, yeah. Let's put that in X. So now we're going to have a look at this guy right here. Enter macro list. Load A. Paste that. At X. Store that into pointer. Data macro plus 0. And plus 1. Okay. So now I've got a pointer to the macro. Okay. Axio, how you doing? Remember back in the day I was using NASM a little bit? Ooh. So these object-oriented features are more of a side effect of some namespace shenanigans and structure shenanigans. But it's a documented side effect, so we're fine. How you doing, by the way? Welcome. Okay, so got a point on the macro now. So now what we can do is load Y, data macro loop, load a pointer, I did that completely backwards, data macro at Y, store that into pointer. Uh-oh. Hang on. Wait a minute. I'm loading from one macro and loading from one pointer, one object into another object. This is gonna be fun. Load Y. Let's keep that stuff in that view. Load what was it? Pointer data inster. Store that pointer chan inster at y. Okay, so the channel instrument. Channel struct, instrument struct, instrument struct. Oh God. Oh, this is gonna be rough. Oh man. It's gonna be very rough. Oh Jesus. Pointer data macro. I need to get a pointer to the destination. Instruct volume load I. Nope. I need to do some more pointer math here. Clear carry. Clear carry. Load that. Add carry to pointer. Inster or chan inster. Plus 0. No. Yes. And then store that into... Oh, God. Hang on. We're going to store that. Pointer macro. Plus 0. Load a 0. Add carry. That was 1. Store that in plus 1. Woo! They don't have sizes. Oh, they got sizes, all right. I know there's some game show on the Xbox Showcase is going to get expected reaction of the right. Oh boy. This isn't like a size issue. It's more of an untangling pointer issue. Untangling where the data is. So this yeah, so the PTR macro, pointer macro, that is the current volume macro that I'm looking at, right? And then copy macro. We're going to do one of those. Okay, this copy macro is going to load up whatever is in pointer data macro and store that into pointer macro. Load y is 0. Okay. Instrument macro struct. This guy here is that. The other one I need is the data macro right here. Loop release data length data. So we got loop release the data length and the data. The running and offset are going to be reset to 0. We're actually going to grab these. I'm going to put them up top like that. Okay. This is also why I'm using the actual names for all these. I'm load y name, even if for now they're right after each other, so I can rearrange the stuff in the structures without breaking anything. Foxcode, how you doing? What assembler am I using? I'm using the CC65 suite. That's CA65 and LD65 specifically. Okay, so first thing we're doing, ooh, no, hang on. I don't want to have these there, actually. Do I? You know what? The way I'm looking at it here is I have a pointer directly into the data to read the macro. So I don't copy the macro data. I just have a pointer to that data. Oh boy. Oh boy. All right, we're gonna do like this. We're gonna have them after all that stuff right there. So I could do here, for the first three, I can, yeah, well, load Y loop, load Y data macro loop, load A, pointer data macro Y, store that pointer macro Y. Because they're going to be the same. I just have to make a note. Do not reorder loop, release, and length. Do not reorder loop, release, and data length. Okay. And then increment Y, paste, increment Y, paste. Release. Loop, release, and length. Okay, then load up load up Y, I'm sorry, data macro data. Before that, we're going to reset the running and the offset. Or let's do that up here. Oh, no, not that far up. Up here. Load A, load Y. I keep doing that. Issue macro struct running. Store A. No. Load A. 0. No, load A 1. Store that into pointer pointer macro at Y. And offset, we're gonna load 0. Okay. Paste that there like that. Okay. Loop release length. Okay, now I need to get the get pointer to data. So I'm gonna load A with that. Add carry. Pointer data macro. Plus 0. Store that into somewhere else. Hang on. Load Y. Instrument macro structure. Pointer. Store A into pointer macro at y. And then we're going to increment y. Load a 0. Add carry. Pointer data macro plus 1. And then store that there. Good. And what machine is a tracker player code for? NES. Or Famicom. NES, Famicom, that kind of stuff. Okay. Pointer to data. Okay, so we have a copy macro now. Good. So that means I need... .2 channel state struct instrument plus instrument struct and macro type. Okay. Pointer data macro needs to point to the macro in the music data. Not. No. I want the ID. Pointer macro, pointer check. Index offset. I want this. I want that in A. A needs the data macro ID. That's what I want. Okay. So let's get rid of this. Well, let's actually instead let's yank that, put it down there, because we're gonna have to do it for every single one anyway, right? Clear carry volume. Okay. Sure. Instrument list pointer instrument. Volume. This one. Okay, so this is what I need to put down there. Data instrument volume. Okay. Volume. Yank. Paste. This one's going to be arpeggio. This is looking better already. And then pitch. Pitch. high pitch. High pitch. And lastly, duty. Oops. Duty. There we go. Okay. So in theory, this should work. In theory. In theory. We'll see if that actually works. Have I written any good chiptunes? No. So I am not a music guy. I'm not the only music I have here, the music I'm working with, I commissioned someone else for. Theory is wonderful. Everything works there. Oh. Yeah, I am tone deaf though. I cannot write a tune to save my life. So I commissioned that out to someone else. Okay, so get rid of all this crap here. Yeah, I only got up to like arpeggio. That was the second macro. And in that little bit of time, I just wrote code for all 5 of them. What is this? Wait a minute. Okay, macro, got it. Let's see it up there. Get rid of that. Okay. Okay. Let's want us do that, right? A lot of things that don't work in theory. Like how we ever get, how we ever be able to get 1 = 2. Some funny math that happened in that, I think, right? That's not what I wanted to do. I didn't want to go all the way up there. God damn it! Now where the hell was I? There we are. Copy macro. Okay, so that should work. What the fuck is this? This is not Java. This is pretty far from Java, actually. Welcome. How you doing? Thank you for the follow. Appreciate that. Freddy. FN. Wait. Okay. Get an argument. No. What do I have here? So I've got pointer channel, right? Yeah. Yeah, how do you get Java out of this, right? And the channel structure has weight. So, all we're going to do, increment y, get argument, RTS. No, this needs to increment something, doesn't it? Increment channel. What does this actually do? Channel state structure read offset. Yeah, it needs to double increment. Oops. 'Cause I'm pretty sure that's what that double increment is. Yeah, it's the read off. Okay, yeah. Yeah, because the data here, right. Load instrument data. Wait data. Okay. So yeah, that's going to be jump to that one. Double increment channel. Load Y. Huh? Wait a minute. Wait. Offset. Oh, that's disgusting. No, we ain't doing that. No. Load Y. Channel state structure. Wait. Store that into pointer channel at Y. Get argument, then store it. Then double increment the channel. Because that will increment the read offset twice. Compared to Java, you're more insane to use this than Java. Shut up, Joe Mega. All right. The halt. Write this after instruments are implemented. Okay, well, instruments should be, in theory, implemented now. Stop the currently playing instrument for the current channel. Okay, so that is just... I need to update the buffer to... put 0 on everything, essentially. And... I need to set the running to... Well, 1, I guess. Well, no. I need to set the buffers and then clear the running flag. Okay. Yeah. I mean, you're more insane to use Java. Fuck, typing is hard. Yeah, I say. How can you not like the amount of indirect index and addressing with the Y registers going there? It's so much. So many indirects. And it was... oh, God. It was worse, if you want to believe that. It was worse. So all this, like, ch underscore something or other, that was a temporary variable that I loaded some crap into and then, like, called functions for. And then turned around and then loaded up or moved these temporary variables back to, like, their channel-specific things. And it just made everything so much worse. All right. Stop the computers. Okay, so we're gonna load up a 0. Load Y. Instrument structure. Wait. Instrument macro struct. Fuck. Do I need that in there, actually? Like, do I need that in the macro itself? Okay, no. Yeah, yes and no. The instrument stuff that I literally just did. I need something else in here. Okay. So for all of these, for this copy macro stuff, if A is 255, FF. If it is, I need to disable it. Okay. Because there's nothing to copy from. Next titles is expected, but still feels like a spoiler somehow. I did see it. I watched it just before stream. It's really so fucking creep. You know that? Fucking creep. Goddamn. Serves him right that she didn't immediately recognize him. Serves him right. Okay. Anyway, okay, so disable, which means, what the hell does that mean? I need to put 0 in running. So yank that. We're not gonna. Am I gonna bother with everything else? I don't think I'm gonna bother setting the other data, the other fields. I don't think I do, so I'm just not gonna. Because who cares, right? Someone needs to tell Rudy this. Dude, don't smell your former teacher, you fucking weirdo. You fucking weirdo. No. That's the first thing he does. Before he even realizes that she doesn't recognize him. So it comes off as extra fucking creepy. God. Anyway, okay, so I got the running bit. Not the skip. Let's go down to the next one here. This, no. Wait, no. Halt. Okay. So this one, instruct, I need to go through each. No, I don't need to go through each one of them. I like. Wait, read off the current frame, current length, tick, right, last note, frames, or instrument. You know what? I think I do, because I don't have a running anywhere else. I have them only in those. Damn it. Okay, well. Volume plus running store into pointer chan instrument at Y, paste, so not volume but arpeggio, and then pitch, high pitch. Thank you for the follow, by the way. Appreciate that. And duty. That's what I wanted. Okay. And this, yank, go to the end, paste. 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 Okay. Whoop. And then get rid of that. And then, okay, do I have, I should have the buffer in here somewhere, right? Process channel. Pointer buffer is pointer to the buffer. Okay. Load A. Buffer, pointer, buffer. Nope. Buffer. Channel buffer. Ready. That's not A, that's Y. Store A. Store A into pointer buffer at Y. Load A 0. Timer low. Timer high. duty volume and sweep. Okay. That's the halt. So we clear out the runnings, clear out the buffer, and set the buffer to ready. Okay, so it writes to the next time around. Good. Something good. Dragon remembers woman's name, proceeds to get tortured by okay. I don't know if any of these others are actually used. So I'm going to put a break in all these. Like that. Can I tell the difference between a break and a IRQ? I forget. What's different between the two? Are like flags set differently or something? Is that what it is? Probably get the second bite the previous anything sort of stack all versus the breaking structures. It can return to it. Okay. Transfer controller interrupt vector. Other than changing the program counter, the break instruction changes no values in either registers or the flags. Break instruction is a single bit instruction that is addressing was implied. Okay. Isolate B flag. B flag. Most of the use for break instruction is during program debugging, sure. When the user decides that the particular program is not operating correctly, may decide to patch in the break instruction over some code that already exists and halt the program when it gets to that point. Okay. In order to minimize hardware costs, the break, which is applicable for debug, only for debugging, the microprocessor makes use of the interrupt vector point to allow the user to trap out that a break has occurred. In order to know whether the vector was fetched in response to an interrupt or a response to a break instruction, the B flag is stored on the stack at stack pointer +1, containing 5, one on the break bit position, containing A1 in the break bit position, indicating the interrupt was caused by a break instruction. The B bit stack pointer contains 0 if it was caused by a normal IRQ. Therefore, the coding to analyze for this should this as follows. Examples in line 6. Okay. Status register, restore to stack. Isolate the B flag. Okay. Okay. Let me just load a Balin. Debugger. No. Which one's a B flag? Not that one. This one. Huh? Appendices, right. These aren't the appendices. That's the appendices. This. Sets interrupt. Okay. Does IRQ do the same thing? IRQ doesn't then, right? Parakeet does not. Snipe, I don't. Just seems wrong. It's better than what I was doing before, okay? It's a lot more sane than what I was doing before, believe it or not. So it'd be this bit, right? Yeah, but just be happy I'm not working on PLB, right? But okay, so if well, I'm not gonna actually worry about it because yeah, I'm not gonna worry about it because I'll just have a break on those. I'll just have a break on those. It doesn't matter. It doesn't matter. It's fine. It's fine probably. I need to remove these for for actual code. But don't worry about it. That's fine. If you use a break or IQ, make sure your vector is set up right. So that's the thing. I am writing code that isn't expecting those to be set up correctly. So I'm putting these breaks in now just so I can see if those are ever called. Right? And I'll deal with it when I get there, I guess. All right. Make. Simple song meta undefined. Okay, fine. Expand from here. Sure. I need to fix the load song stuff. Simple volume is undefined. And then 1,000. Channel buffer volume. Because that... Okay, yep. Because that is old code. Channel struct tick 0 pointer channel. Okay. Channel, is tick still a thing? It is. Okay. I need to figure out what the hell tick rate's supposed to be, too. Noise stuff. Channel buffer volume. No, that needs to be duty volume, probably, right? Or, no, I need to actually mash these up to what the others use. So, for the pulse, volume is the first register. For noise, it is also the first. Okay. So I can use the duty vol. Envelope, loop, length counter, constant volume. So, yeah. Duty vol. Load data. No. We need to load that, and we need to or it with that. Because constant volume. What I did. Is data, like, is that actually populated? Yes, okay. It actually is populated. Channel ID, I believe, is actually still used. This is the only one that's used. CHID. At least it should be the only one that's used. God damn it. God damn it. Okay. It's the only one that's supposed to be used. Buffer ready period. Ooh. Ooh, no. This is all wrong now. Increment offset. Load watch. Nope. Not doing any of that. What we need to do, though, is we need to increment the channel. We need to double increment the channel. Here. 2. Okay. Instruct state ready. What the fuck is the ready actually doing here? Oh, that's buffer shit. I don't care about that. How do I channel buffer ready? Just throw that there. Buffer, how you doing? Welcome. So we can make great sounding snare drums. Well, maybe. Marion, how you doing? Welcome. This isn't being used anymore. Because that's all somewhere else now. Like, that's not... Huh? Load Y offset. That... No! Huh? Set volume pointer macro... Huh? Is all this crap wrong up here? Wait a minute. Buffer channel duty volume. Load that and or that. All right. Clear everything set with duty. Set constant volume. What the fuck? Hold up. Whoa. What the fuck is going on here? Process. What's cooking? I am trying to untangle some stuff. Trying to figure out what is old code and what is new code that I wrote. This looks like a lot of old code. Get the delta value. No. This is new code. Track and play routine, but I think there's not enough love for the X register in this code. Yeah. Well, using X with pointer stuff is a bit more of a pain in the ass. So... have we gotten that far? We've gotten decently far, I think. Yeah. But this isn't right. That's not right. Also, no, that's not even. Huh? Set volume. Wait a minute. That's not even right. What am I trying to do here? Instrument volume. Instrument volume. JSR load macro. Instrument field and Y. Strike pointer and macro. Pointer macro struct. Where the hell is that pointer? Way down here. That. Put that up there. That there. These are going to be the same thing, aren't they? Yeah, Dash, no worries. Thanks for stopping by. I appreciate it. Fucking what? Am I duplicating this code? I think I am duplicating the load macro. Because somewhere else, down here, well, I mean, no. Okay, so the load macro, that's actually doing something different, I think. Right. Instrument field in Y, struct pointer and macro struct. Oh yeah, because that's actually processing it, right? That's not loading it up. That's actually doing the processing of that macro, right? Basically. Loop release length offset. Why am I actually using those? Check loop to verify these. Compare offset. Check loop. Check loop. Thank you for the sub. Appreciate that. Or, excuse me, thank you for someone gifting a sub. Appreciate that. Not running. Okay, yeah. Release an offset. Check loop. Store that in offset RTS. Okay. Offset here being a temporary variable that's used specifically in this code right here. That's fine. Okay. So where was this? Process instrument. What the hell is this? What am I doing here? What am I doing? I shouldn't be loading the value, the address value of offset. I shouldn't be doing that. Or pointer macro Y, set the volume. What the fuck? What the fuck? No. That is offset into the macro itself. From the load macro stuff. Okay. Because I'm doing the same thing here. All right. Yep. Okay. Okay. Let's go over here. Let's make again. Can we fix that song meta crap? Init. Okay, I don't even load up like the fucking thing I'm supposed to be playing. Music, ASM, song meta, no, song list. We're gonna, song 0, song 1. Load up. Low byte. Song 0. Store that into pointer A plus 0. Nope, song 0, and then high byte plus 1. Then we're gonna jump to init. And then the init code is gonna handle that. Um, okay. Save that for later. Pointer A undefined. Go to hell. Okay. Sound in it undefined. Engine flags. Well, noise pointers undefined. 30307. I just had these completely wrong. I'll say state. Because I did actually change those. State, frames, and orders. Okay. This is going to get wide. Well, no, this isn't going to get too wide. This is just going to be getting shorter, actually, if anything. Yeah. Oops. Okay. Frameless pulse A, undefined. That is in 291. Song... Data song meta... Frameless pulse A. Because I spelled something wrong. Duty vol, undefined. Where? 212. Load 7F. Disable left the counter. Should that just be part of the buffer stuff that I do? Not that one. Nope, too far back. That's... Huh? What? What? Would that be... No. What the... What am I... This doesn't make any sense here. What am I doing here? Land counter halt L. That just needs to... What? Um. No. Let's actually just go to write buffers. To devolve. Okay. Compare X to 2? No, I want less than. So if I set to 3 and then just do reset, carry clear. Okay. 3, branch carry clear. Array. That is. I like the sweep. One infinite play. Okay. So 0, 0, 1. Okay. That should work. Probably. Right? Right. Okay. I don't actually load up the song. Process sounds for this frame. 100 flags. Okay, where are my engine flags? There. Ready. Enable song. Okay, well. Oh, right. Okay. Yeah, that's fine. Whatever. Clear buffers. So we're just gonna RTS because I need to load up a song. Now then, where do I ever have a pointer to the current song? Do I have that somewhere? No. No, I did not. Okay. Get rid of that. Clear buffer, reset channel states. I gotta figure that one out. Yeah. Data song meta, because I need to load up all this crap. And put it into there, basically. This is gonna be a roll a pain in the butt. Let me hit the bathroom real quick. I'll be right back. Don't go anywhere. Do I have? I'm back. Okay. So basically, I need to load up all of the channel states. So is there points of the full structure? Yes. So we've got a pointer to this in A. Pulse A. Let's load up Pulse A. So well, what assembler has these kinds of directives? This is the CA65 assembler, or it's part of the CC65 suite. Welcome, though. How you doing? Everyone can play. Nice name. Nice. Okay, so I'm going to load up Y data song meta. Orders pulse A. Load A. Pointer A. So if it's a what machine? NES. Welcome, by the way. Devros? Am I saying that right? Devrossi? And yeah, XFCE just gets out of my way, and I like that about it. So, load it up at Y. Store that into Pulse A. Not a buffer. Nope. State plus channel state structure plus. No, not that. Orders plus 0. Then yank that, put it there. Or just this is gonna be increment Y, and then plus 1. And then for the frames, like that. Dravos 1. Ah, got it. Dravos, welcome. Structure enum. These are structures. .struct. There are enums, but you know. What specifically gives you to nostalgia? I'm not really working on nostalgia for this. It's more of the inner workings of the games. I had a BBC Micro in the 8-bit days. Ooh, nice. Yeah, my first console was actually a GameCube back in fucking high school, I think. Yeah, a bit of archaeology. So a lot of some of the other stuff I do here on stream is reverse engineer this thing, which is a Famicom. I hesitate to say cartridge, but device that's got a tape drive on it. It's a funny one. On the tape is recorded audio and data, both on the two channels. One channel has the audio, one channel has the data, and the tapes contain like English lessons and math and science lessons and stuff. These are fun. These are the code here is jank as hell, and it does some really stupid shit, and some really convoluted stuff as well. But it's That's a work in progress. That's a work in progress. We're figuring that out a little bit here and there. I'm not doing that tonight though. How does an assembler have directors for C-like structures and enums? These are just aliases, really. They're not true structures. They are what's the word? I want to say name table. That's not it. They're what's the name that I can see it in my head. Almost see it in my head. Namespace. That's it. They're namespaces, essentially. They're a side effect of the namespaces. All this really is a number. It's an offset. That's all it is. So what I'm doing here, pulse A state, that's basically a value, right? That's a memory location. And I'm saying, hey, at that memory location, add this offset to it. Okay, thanks. Because at that memory location, I am... it's this right here. Specifically for pulse A state. This tag, all this really does is go, hey, get the size of this, whatever this structure is, get the size of that. We're going to make this variable that size. That's all that does. So then this, well, label technically, just is defined as the one after this label, right? It's the next address after that size, basically. So it's all just offsets and offsets and labels all the way down, pretty much. So when I load this stuff up in the emulator, this is not it. Let me load up. Nope. File. Recent. Sound engine. Don't ignore all of that. It's wrong. Actually, can I assemble this real quick? Make. I cannot. Frames pulse A undefined. 224. Frame list. Damn it. Why do I do frame list and then... Hang on. No, I'm just going to... Frames. There. Make. Frame list. Shit! 3, 2, 2, 2, 4. There it is. That's not a pattern. That's a frameless noise. Frames noise. 317. Okay. Okay. All right, now if I go over to debug and debugger, and I go over to what code was I just looking at there? That was the init code, wasn't it? Yeah, init code. Init. This guy here. So yeah, it's all just numbers all the way down and offsets, right? Load Y and offset. Look at that pointer at that offset. That's all it is. Kisco, how you doing? Object-oriented design. That's a coincidence. I was just doing functional HTML. HTML is barely functional. What are you talking about? What's the difference between the line above which uses index absolute addressing mode to load the accumulator, the line below where you store the value of the accumulator at an address using the plus thing? Oh, yeah. So this right here. So when I'm call into init, right? Main.asm. So that init call is right here, right? This sound engine thing is only because the engine code is in a namespace, so I can not have to worry about colliding labels and names and crap. That's all that really is, right? So this sound engine pointer A is the same as pointer A over here. So what I'm doing is I'm loading my my music data, or a pointer to the music data, right? So that low byte, high byte thing, music ASM, song 0. So this song 0 exists somewhere in the ROM, right? So these are basically saying, hey, load up the low byte, the first byte of the address for this label. So now in A, it's got the low byte of basically that data right there. And then this is the high byte doing the same thing, right? High byte of that drops in the pointer, and then we're calling up init, right? So pointer A, right here, points to that byte right there, that 64, right? This right here, data underscore song meta, that is this guy right here, over here. That's this defined structure, so I can use these names to reference the data in there, right? So that first value right there, that 64, that's the number of rows. The next one, 8, that's the speed. 150, that's the tempo right there, right? So I want to look at orders pulse A. So that's this one right here, right? That is that guy. That data right there. So what I'm trying to do here is I want to get this pointer. So that dot word is the address of this label right here. It's the address of those 2 bytes. Right? So I want to get that address out of that and put it somewhere else. So I'm getting that address. That's what this right here is. Right? And then this, I already know exactly where that's going, right? That's going to go into the pulse A state structure. There's one structure for that. Whereas here, hey, just give me a song. I don't know where it is. There's a few songs here. I have 4 of them listed out, right? They all have the same exact structure, right? So if I go to song 1, it's got the same exact structure. So if I have song 1 into pointer A, right, that address there, it'll instead look at the address for this label, right? But they're all going to the same spot, right? It's like a many to one relation, kind of, right? So this pulse A state, there's only one pulse A on the system. There's 2 pulse channels. One's named pulse A, the other one being pulse B. And I'm storing this at a specific address. Whereas here, it's not a specific address. It's at an offset of some random address you give me, right? But this is a specific address, and that you can see it reflected here. So this is that code assembled. That load Y D, 0D, that's this value right here. That assembles into D. Load A at the pointer, right? And store it right there, 216. That pulse A state plus the channel state structure plus order 0, that assembles down to that address right there, 216. And then the next line, you can see that's the same thing, plus 1. That's 217, right? Because pulse A state, this right here, is defined in my RAM. That's the OIM, right? And that RAM, that's going to be... Where's the config for this thing? This guy. This is my linker configuration. So that OIM, that's this guy right here, saying load up the OIM memory. OIM memory right here starts at address 200. So we are 17 bytes into memory. That's where pulse A state starts. Right? Or that's what the orders is, technically. Not pulse A, but the orders. Yeah. It's down. No, that's... Excuse me. Channel struct. That's down here, right? Or down here for the orders. And if we have a look at... Oh, yeah. So, yeah, look at the OIM over here. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, Starts at 13. All right, 13. And then 13, 14, 14, 15, 16, 17, 18, 19, 20, 21. I forgot base 16, not base 10. So 17 isn't, it's 17 hex into that. So if I bring up here, 17 hex, 17 hex to decimal, 23. Yeah. So 23 bytes into memory is where that goes. Well, for 17, not to 16. 16 is a one less. Would you say that Go and C are the same paradigm-wise? I don't know a lot of C. I know how to break C. Paradigm-wise, I mean, not really. Because you handle stuff very differently in those two languages. Very differently. I mean, they have like similar syntax sometimes, but once you start working in either language or in both languages, you can tell the difference pretty fast, right? Like the way pointers are handled is completely different. Go has really easy Go routines, or it's not multi-threading technically. It's more complicated than that, but it's asynchronous-ish kind of stuff, co-processing, more or less. Whereas in C, you don't really have that. I mean, if you want threads, you need to make sure that your OS can handle them. And if not, you gotta roll your own, essentially, right? C has single return. There's only one return value. So in C, you'll be passing in pointers to functions, right? Where I want the output in this pointer, in this structure, right? And then the return value will be your error, right? Or something along those lines. Whereas in Go, you can just return as much as you fucking want. It's weird to call them pointers when you work directly with memory. Here I am using pointers. I mean, oh, I got caps on. That's why. I'm using pointers all over the place. This is a pointer. Pointer A. That's a pointer. That's implemented in the instruction set as a pointer. Because that'll have a memory address in it. Pointer A, right? So if I look over here, pointer A, this view of memory. Oh, that's the first, yeah, right there. So that has this data in it. 02D7. So I load up Y with that. That should be D8 though. Oh, because Y's got 1 in it. All right, so ignore the D there. Y has 1 in it currently. That's why it says 2D8. So it's looking at that address, right? So it's not going to look at this right here for the data. It's going to look right here for the address to then look at the data, right? Let me put a breakpoint here. And then we'll just... Where the hell... We'll just reload that. Okay. Put that back there. So, load Y, D. So we've got D and Y, you can see up here. So now, pointer A, 86E0. But that's not where we're getting our data. We're getting our data from 86ED. Right? Because we took this address right here and added the value of Y to it. And that's where our data actually lives. 86ED. Let's go down there. 8 4 6 A B C D E. There's our data. A4. ED. I read it backwards. ED. 3B. That's it. 3B. And you can see 3B is our data. Yep. The 2600 doesn't have higher concept stuff. I mean, so this is the same processor as the 2600. Kind of. With a big asterisk there. Do I know that name? Do I know who that is? Should I know who that is? I don't know. I feel like I should know who that is. But yeah, so I am working with pointers here. That's what all this comma y stuff is, or the parentheses comma y. For this stuff here, address comma y, that is just, hey, look at this label and add y to that label directly, right? Nobody new type, how you doing? What type of what is that debugger software? This is the emulator Messin, which is a NES emulator, among other things. This right here. So if I recent files and go over to, let's go over here. And it's an NES emulator that has a beautiful debugger attached to it. Yeah, this is what I'm using. Recent send engine. Excuse me. No, 6507 has 12 edge. Yeah, they chopped. It's a 6502 core, and they chopped off a bunch of pins. Not just the address pins, by the way. They chopped off, I think, the IRQ pin as well, or the NMI pin. Maybe it was. I don't know. They chopped off too many fucking pins. So the Atari does some god awful stuff, where it runs code for a single scanline beam, and then halts the processor until the next scan line. What? So the whole chasing the beam. Yeah, you had to be very precise with your timings on the 2600, because you literally needed to chase the beam. So here on the NES, let me get one of them that'll make a little more sense here. Okay. Or let's start this real quick so I can demonstrate some things. Come on, freaking there it goes. Okay. Okay, that's good enough right there. So, debug sprite viewer. So I've got some sprites to work with. I've got 64 of them. I don't know how many the Atari had. 3. And they weren't like 8 pixels by 8 pixels. No. No, it was 8 bits. You had to change it every scan line. You had to change it. And you had to do it yourself. Each scan line could have 3 sprites or objects. Takes 2 sprites. Was it 2? Because it was the 2 players and then the ball object or whatever, right? But it's like 3 bytes, if anything. At most. Right? Wrong account, BRB. What? Okay. I don't actually have experience on the 2600. I need to do something on the 2600. I've read up on it. I went, damn, that's crazy. That was you. That was you. Okay. Welcome, undeclared. But yeah, so for the NES, what I have here, this is all RAM, right? Up to there, right there. That is what I have internally for RAM. That doesn't seem like much until you realize the Atari had that much RAM. For everything! Follow my brand account. No worries. Now, if you're unfamiliar with the 6502, that might not sound terrible, right? Except there's a hard-coded stack on the 6502. This page right here, the hex 100 range, is the hardware stack of the 6502. You can see values here, right? Anytime you jump into a routine, your return address is pushed here. It grows up, right? So it starts at the very bottom, right? So it starts at 1FF, and it grows up, right? So the more routines you jump into, the bigger this gets up, right? But that's at hex 100. Like, the address range ends at 80, doesn't it? Well, kind of. That address range on the Atari is mirrored. So writes that happen here also happen here. Which also means you can't use too many variables or you start hitting stack space. Conversely, if you nest too much into subroutines, you start clobbering your variables. Fun. Also, you only have like half the cartridge space to work with because reasons. Missile sprite, got it. 2600 programming is, I hate myself, right? I need to try some 2600 stuff. I need to try on that system. I have one. I don't have a ROM cart for it though. I need to get a ROM cart for the 2600. They do exist, right? So I have these, by the way. I've got a few of these. I don't have the Mega Drive. I've got this guy here. Got the Game Boy Advance one, whatever that is. I got this. Well, I don't have that one. I got the non-pro version of that, which is kind of crap. Cartridges. Mega Drive, Master, GG, Game Gear. See, I've got that one. I got that one. That's another Mega. I don't have that system. Does he not have one for that? That's unfortunate. That's unfortunate. Let me bring it over here. Let's see. ROM cartridge. Does that actually exist? Instructables. That's not what I wanted. I don't know. A load of ramen jar cartridges. That's not really what I want. I don't know. If I had more than 128 bytes, I wouldn't consider all the addresses. I couldn't remember all the addresses for the T registers. 24 games would he having to use the Atari? No, it's like, we don't like doing compression. Here's a 120 gigabyte gaming door with bad memory management. I mean, I don't know. They'll do compression to a point, right? But images and stuff doesn't really compress very well. Images don't really compress very well, you know? Losslessly. Lossy, they'll... Yeah, it's 120 gigs with compression. Yeah, ask Joe Mega that. Yeah. Yeah. Well, so Joe Mega works in the industry. How big is your current repo that you're working on? How many terabytes? About 2. Okay. All right. Yeah, imagine a 2 terabyte download for a game. For one game. Imagine that instead. Compression's a lot of fun. I do compression on the NES as well, and it's different depending on what I'm compressing too. You know, because some of it's more of like a what's it? Like a metadata kind of thing. That's the data, not just code. Oh boy. But stuff for like the maps and the not maps, but the screens and stuff on the NES here. I don't like save the full name table. Like this is actually one of my earlier ROMs that I made. So this auto generates actually. Didn't I? I thought I had that bound to escape. Oh well. Is this okay? I've got A bound. All right, that's cool. But all the stuff in here is all like auto generator, right? And I don't. That's a good spot to pause it. But I don't like store these full objects or whatever in the data, right? Like I reference them as like meta tiles and whatnot, and go, oh, I want this meta column, and this meta column is made up of these meta tiles, kind of thing, you know. So there's different ways to compress things, depending on what you're doing. You know, 1.2 petabytes, really? Wish they want they paid for the storage bill. Go to my salary instead. Oh, wow. Give you an idea, modern games generally use BC7 compression for images, which is 128 bits per 4x4 pixel block. I don't think I've heard of that. Well, not that I do or work with that. So, Stray Dog, how you doing? Welcome. 128 bits per 4x4 pixel block. That sounds like a lot. I don't know. I think it'd be cool to see stream about PTX programming. PTX? PTX. I don't know if I know what that is. Is that a console? Oh, CUDA. CUDA stuff. That's a bit too new for what I usually work on. Yeah, I'm doing all the retro stuff. But anyway, what was I? Reset channel states. Do I do any of this? Clear all channel states, includes industry channel. No. Instead. Oh no! I only load up Pulse A. I need to load up the others. Pulse B. So yank that, put it there. B. Like that. BC7 can actually encode an image in 8 different ways. The type encoded in those blocks, but it's not a simple compression system. I feel like it initially, but very fast on hardware. Oh. Unfortunately, 2008 to 2010 NVIDIA GPUs were programmed using PTX. Ah. Mode 0, 1, 2, 3, 4, 5, 6, 7. I have a feeling that Mode 7 has nothing to do with SNES Mode 7. Neat. All right. Pulse B, and then I need... Nope. triangle. And then noise, lastly. Let's do it like this instead. Noise, so I can do these a little easier. There it goes. Oh, I missed one. Good. Okay, so I load up all those. And then load up a 0. Paste. Wait, 0. Wait, and then read offset. Well, yeah. Tick. Current frame. Last note. Ready. Okay. Nope. There. Nope. Pulse A. And pulse B. All right, clear out a bunch of stuff there. Instrument. Do I want to clear out all that crap too? Is this used anywhere else? Yes. Load song. Do I use this anywhere? Hang on. No. Why? I should be using this. Pointer song meta. Let's just... Okay, Mr. Channel states... What the hell is this? Chelsea starts Chelsea like global. No, get rid of that. Order ID, sure. And here, this stuff we're gonna get rid of. Next song on A, no. Instead, song pointer pointer A. So we're not doing any of this. We're not doing... Well, we are doing, but we're gonna... Load a pointer A plus 0. Pointer A plus 1. So pointer song meta. Good. So then for init, state orders. Hang on, don't I load song? Doesn't this do the state stuff as well? The frames? Yes, it does. Okay, so I'm duplicating this crap. I don't need to do any of that, because I already do it. Damn it. Okay. I don't know why I need two separate routines for this, init and load song. I don't know. Has some fixed sets, which decide which two source files to use, and then interpolates between them. Oh. This is probably the simplest. You have an 8-bit min and max color with lowest bits for a component encoded into a separate bit. And then it has 4-bit values to interpolate between those two colors. Oh. Huh. Great. Okay. Make. Let's see what this sounds like, if anything. Okay, so. Song 0. That should sound like game reload. This. That's what it should sound like. Because that's the song I'm loading. Right? Now then, race and files, a sound engine. What do we got? Fuck all's what we got. That didn't even start. Okay, let's get to NMI. God, this fucking scroll again. I hope he fixes that soon. Write buffers, write to okay, I need to not do those, but write buffers. F11, yeah. Write buffers. There shouldn't be anything in these buffers. Right, not ready. Not ready. Not ready. Not ready. Not ready. Right, debug don't care. Update debug don't care. Sound process. Load engine flags. And it with 1. Branch not equal. Clear buffers. Decrement the tick. Load the tick. Branch equal. It's not time to read the... Okay. Well, I want to, so we're going to put up right there. Does that never kick off? What? Two. Clear buffers. Decrement. Load. Okay. Decrement. Branch equal. Okay. Load speed starting to tick. That's wrong. Load the flags. Branch minus. Sound effects crap. Okay. Enable flag, enable song. Okay, so it's enabled. Load order. Branch equal. Pulse A. Okay. Process channel. What is that one? Jeffrey Way, if not zero decrement. Branch equal. Okay, so we're ready to do the stuff. Is my hang on, let me settings, no, debug, no, over here, debug. Because everything's zeros here. All right. I said delete that, damn it. Delete, I don't need that there. Oh, wait, come on. I click them there. F11. Why can I not F11 do this? Jesus. Okay. Load that start pointer channel. Okay, so let's put some pointers in here. Pointer channel. Pointer chan instrument. Pointer frames frame list. That hasn't set yet. Okay. Pointer frame. Okay, get the frame list. Again, come on. The frame list. Points the frame list. Load 8. So 0 frame list plus A. No, it doesn't. That's 0. $200C. Where is that? Where is that? Current song plus 1. Tick, order ID, this is all global stuff. Channel state start. Pulse A state. I think that should load in here. If the program used to read instructions as a debugger, wouldn't that make the editor used to create the instructions a bugger? I mean, I guess. All right, hit play on this again. Because clearly I'm not loading something like I should be loading. I'm not like initializing the fucking song or something. Because all this shit's zeros. Which is why it doesn't want to work. All right, clear buffers. That's clear. Reset channel states. What do these appear? Oh, that's stack space. I don't like how this is just empty too. By the way, like that should actually be, that should have stuff there. Channel state start. Yeah. Anyway. Why are these empty? Just like, is that used anywhere? No. Oh yeah, that crap. Main assembly. What the huh? 4, 7, 8. All this debugging crap is going away. I don't care. God damn it. Not doing it. Not doing it. Ah, it's better. PPU state. That's better. Okay. Okay. Clear. Reset the states. See, that's what I want to see. Load 0. Just put 0 everywhere. Almost everywhere. Store order ID. Okay. RTS. Load song. Pointer A. Pointer song meta. Okay. So, pointer song meta. That is not right. 2D7? No. Because I clobber A, don't I? Yeah, I clobber A. No. Nitrix, how you doing? Let's put it in B, I guess. I mean, this is just terrible, honestly, what I'm doing here. I'm just shuffling pointers around from B to A to pointer song. So whatever. I'll change that in a bit. Reload that. Init. Let's go over here. Pointer A. Pointer B. 861C. That sounds better. Right, because pointer A got clobbered there. We're going to reset states. Why didn't you follow? Put B and A, and then load song. Now, pointer meta has the correct shit in it. So now 8661C. Song 0. There we go. Now we're actually loading up the song data. Got the speed in there. Tick 1. Okay, sure. Tempo, reset states again. Okay, so I don't need to do the reset state on the internet. Okay. Jump to load order. Jump out of all that. No, jump out of. It didn't. Okay, cool. Doesn't know where to jump to, I guess. Load order, RTS. RTS. And I call load song immediately. And immediately break everything that I just did. Don't actually need that there. These can be pointer A again. Don't do any of this. Okay. Dennis! How you doing? I shouldn't. I don't know. How you doing? Welcome. Treff, how you doing? J&E, what, why? I don't have J&E. Jump not equal? I don't have that. Click-clack. Programmer Jeff, how you doing? Welcome, welcome. Dennis, thank you for 21 months, by the way. Appreciate that. These are blue cherries or what? Yes. Yeah, I think these are blues. Yeah, these are blues. These are blues. A lot longer than that. Well, I mean, you got banned a few times, didn't you? I think it clears it after that. That one's on you. Banned for life! For life! Can you hear from Canada typing? 3 times! 3 times. All from what? 3 times live. Yeah. Cherry ones will go to, but now they're meh. Yeah, so I have cherries here, but I don't actually use cherries at work. At work, I use something else. I don't honestly remember what they are. But they feel nice. They feel real nice. Artistic misinterpretation. Yeah. Yeah, it was a stray titty, right? Well, at least one of them was. TKO, I think it is. 60%. Yeah, this guy. So this is what I use at work. This is my board at work, right here. Little 10 keyless. Let me turn that on so I can actually load some of this shit. Go on F5. Thank you. Probably fine. Switches. Okay, I don't think I have hot swaps on them. Are they hot swaps? Kale box, if that's how you pronounce that. They're different, but not a bad different. I actually really like them. Yeah. Gatron and Kale. Yeah, these are actually really nice. I like them. Panda? I don't know. Was pink, yellow, dark rose, pandas, up, down, crystal. New names. Pandas. Yeah. Can you run something for me? Maybe. There was a discussion about random numbers and uniform distribution, wherein I said that a run of events in a row is possible in a uniform random distribution. I know some of those words, but yeah, I can run some for you. What do you want me to run? Can I run that silly code? Sure. Is this new ChatGPT malware? See this. Coin flip. Oh, boy. Okay. What do I need to compile this? Do I need anything crazy, or can I just hit throw this at GCC? Raw. Let me do one of these because I never know where this is gonna end up. Yep, that was a good thing I did that. All right, home code there. Save. Coin flip. What is it? Dash O. Max number of heads in a row, 18. Max number of tails in a row, 25. Wait a minute. C5. What's this now? Are you version 5 escaping clutches? What? 55, run with 55. Oh, it takes 55. Teacher, hope you really want 55. 5, 6, 6, 12. Did I prove something wrong? Or prove you right? That happens in 12 events. Max number of heads in a row, 12. Try 85. 85. It's super exponential. I've noticed. I noticed. How long will this one run? I'm gonna go refill my water while we wait. I'll be right back. Nerds, we stick together. So, on the subject of RNG, on that subject, at work this past week, I was investigating the feasibility of using. I'm gonna get there. We're investigating the feasibility of using client certificates in a client server API thing. During this, I was discovering how god-awful terrible OpenSSL is. Now, granted, I was using Windows at this point with MinGW, I think. So to certificates, right? You generate a certificate and then you want to like sign that with something else, right? With another cert, right? For a lot of that, it's like, okay, so here's your country, here's like the company name kind of thing, right? So I put that in the command line because I don't want to be asked about it because I want it in like a makefile, right? So I'll put it on the command line, dash SUBJ, subject, right? And then in quotes, the bullshit, right? But it's like the format is /C equals the country code, right? So US, right? / whatever else equals company name, that kind of crap, right? I just had two of them in there. Country, company name. It expanded /C to C, program files, get bin C. I'm like, what the fuck are you doing? Why are you expanding that? I took the exact same command, copy pasted it into Linux, and it just worked. The cert didn't work, but that's a different story. Anyway, so I'm venting my frustration on Discord during the week, and someone dropped a link to a talk about one of the OpenBSD guys, and he was talking about why OpenBSD forked OpenSSL into LibreSSL. So during the talk, I was curious, and I just opened up the source to OpenSSL. This talk was 10 years old, and some of the stupid shit he was talking about in OpenSSL is still there. Like EBCDIC support, because shut up, you need that, right? But the RNG portion of this that reminded me of that. So OpenSSL apparently has re-implemented all kinds of RNG bullshit, where LibreSSL went, no, the RNG seed, the RNG, that is in the domain of the operating system, not of this library. If the OS cannot give us good random, die. Right? We're done. Nothing to do. We don't get a good random from the OS. And then OpenSSL will just like fall back to a static fucking string if the planets align. What? Huh? No. And it supports all kinds of bullshit that like died 30 years ago. The hardware just doesn't exist anymore. And if you're trying to use SSL on those machines, you shouldn't be, because those machines didn't know what the fucking internet was. So just got a no-fly list. Legacy compatibility. Yeah, sometimes they just need to not, honestly. As OpenSSL also makes you target a Giatan, CXZ. Was that part of the path that took advantage of it? Was OpenSSL via SSH or some bullshit? Someone probably in the U.S. government, someone who's using an app 20 years ago. 20 isn't that long. If things don't go well, SSL will revert to crap. Yeah. That's 2004. Right, that's rookie note. I work with code that's older than that at work on a daily basis. On a daily basis. OpenSSL Itanium? Itanium? Well, this is you. I get proposals from people regarding code from the 1970s. Oh my god. I'll say for Wi-Fi. How you doing? I work with a mix of Linux and Windows at my day job. The head of IT, by the way, fucking brain dead. Different story. Okay, so they installed virus scanners on everything at work because fuck you, right? Whatever. Push down from up top or some bullshit. Fine. It scans every goddamn open file that's being read. Everything. Any reads or writes disk, it scans that at runtime. Which is a problem because all of our programs all their temporary like working data is in files because it's all in PLB, which is worse COBOL. Just don't worry about it. Anyway, so it's bringing these systems to their knees. Like, there's soft lockups all the time. Things like K-Worker is soft locking. Kernel shit is soft locking. Like, no, what? What? If you're soft locking the kernel, you're doing something fucking wrong. So it turns out that the virus scanner is just chewing through all this shit, right? So I brought this up to the head of IT, go like, hey, fucking stop it. Stop doing this. It's killing the servers. Like, it's not providing any. We're reading text data. It's text data. It's not fucking program data. It's goddamn text. We're not executing any of it. Stop fucking scanning it. It's Anyway, so I wanted to demonstrate that the virus scanner was doing this. So what I did, grep a string that I knew was going to be in a bunch of files. In this case, it was like ZZZZ. Don't worry about it. It's the print files that we actually generate. Did that string was a zgrep, zgrep, that string, star.z, capital Z, because don't worry about that. Don't worry about that's not really the important bit. And I piped that all to dev null, right? I don't care about the output, just do it. Meanwhile, I'm looking at top, right? Run the command, immediately the virus scanner hits 80% usage. Took a screenshot of it, sent it over to the IT head. Like, hey, I just demonstrated that the virus scanner is getting in the way of all I/O. And he goes, well, that's non-standard usage because you're running grep and that's not standard. I'm like, what the fuck are you talking about, huh? What do you mean that's not standard usage? And he goes, yeah. Oh, hey, let me bring up the screenshot that I took so I can give the exact responses. I'm not gonna show the screenshot because it's got like names and crap in it. I can't show that. I almost accidentally did too. Yeah, likely the AI recognizing a non-typical action. And I go, I'm sorry, AI? And I'm calling BS on non-typical action. It's triggering on basically all file I/O. So I'll have a look. And by the way, zgrep searching for files isn't what a typical use is doing. So not BS. What do you mean not I use grep every fucking day at work. What are you talking about non-typical? Huh? That's what I told him. I use that bolt all the time. What do you want about Mao? Zgrep is how I find sequence numbers and things and other crap from print files. For this test file that one of the CSRs bitches at me about. That ZZZZ string, by the way, is to find the sequence number. Thanks. I knew how it functions. Zgrep is a fave of hackers looking for passwords. Huh? Come again? What the fuck did you say to me? What the huh? What? I don't know how to respond to that. Zgrep is a fave of hackers looking for passwords. If you can grep for passwords, you're doing something fucking wrong. God damn. I've been thinking about this all fucking weekend. I can't. This happened on Friday morning, 11 a.m. I couldn't do work the rest of the day. That's how bad this fucked me up. Huh? I responded. I don't even know how to respond to that statement. Zgrep is a common tool that's installed on every Linux box. Duh, and I'm saying it's used by hackers. What? What? I don't know how to respond to this. Because the head of IT is a buffoon. He's a moron. What is this? Can I really detect your emotions? It's gonna be a no, isn't it? So I actually read it's because I see it. Not this one actually. It's a new CEO, new CTO. I've actually had the CTO tell me directly to be easy on the head of IT. It's a hard job. I'm like, yeah, I get that. He's a fucking moron though. He's an idiot that doesn't know what he's talking about. I work with him and I try my hardest not to piss him off. God damn, it's hard. What is this?
There are some companies now that claim that they have an AI that can tell how you're feeling, whether you're happy or sad or stressed or worried.
Let's see.
Based on an image of your face. And that claim, my friends, is absolute bullshit.
I know
I'm here
it.
to tell you why. And we should know.
Oh, what did I say just now? And I can prove it using 90 seconds using the Kuleshov effect. Am I saying that right? Kuleshov?
And we should know that this is bullshit because of something called the Kuleshov effect, which was named after its inventor in the 1920s. A staple
20s.
of cinematic design, something that was explained quite beautifully by Alfred Hitchcock in the 1960s using this clip.
Oxford, okay.
So first, take a look at this. This is Alfred Hitchcock. He's standing there, kind of a blank expression. And then it cuts away to an image of a woman playing with a little baby. You then go back to Alfred Hitchcock and he does a little smile. This is a kindly man. This is a nice man. He's seeing the warmness of the moment. It's lovely. But now, watch the exact same clip of Hitchcock again, except this time interspersed with a picture of a woman sunbathing in a bikini. Now, when you go back to the character Hitchcock has created smiling, you don't think that he's a sweet old man at all. You think he's a dirty old man. Now, Hitchcock was a dirty old man, but that's not the point. The point is that you cannot accurately judge somebody's emotions from a picture of their face alone. You need the context of the situation in order to be able to determine how someone else is feeling. And any algorithm or AI that claims that it can do otherwise is bullshit.
It's bullshit. I like your accent. That's nice. Yeah. Oh, yeah. So this whole like AI bullshit. Oh my God, this AI bullshit. My boss wants to bring it in to help us understand the PLB code. I told him blankly and bluntly, no, I don't want anything to do with it. I refuse. I told him in front of everybody, I refuse to work with AI generated code. Period. I refuse. No. Are you going to fire me over it? Do it, coward. So he wasn't convinced. So I sent him some code. He wanted me to send him some code. I knew exactly what I was going to do with it. And he threw it at Chat Jeopardy. He sends the code back, and I'm like, this is fucking useless. So if you threw like Python at it, maybe it might be able to parse what it is. I got that from Prime, the Primogen. That's Chat Jeopardy. I loved it. It's because it takes the piss out of it. Got by 8 on. These is around for the week. I'll get back to that in a second. So it took the code. I don't think I have any of the code that I sent it on me. Because a bunch of it is stuff that I can't really show on stream. But some of it, I think I posted in Discord. Let me see if I can find it real quick. Where? But it's PLB code, right? Here's some of it. All right. PLB code. Looks kind of like this, right? This is part of it. This is disgusting. It actually somehow correctly identified that this needed to be a loop and made it a loop. Sure. Underneath that, there's a bunch of print statements that it didn't fucking do. Snippet, yeah. Did I have the result? I don't think I have the result of that. Damn. It fucking gave up. It literally gave up in a bunch of it, right? I could have swore I had some other screenshots of this. No. God, I don't have screenshots of the actual code that I gave back. But a lot of it, like, so this was in report generation crap. So it does a bunch of calculations and prints those calculations out, right? And you can see here, this is all like two-dimensional arrays, right? So it's got like fucking 20 elements with like 5 or something like that. Maybe 3 elements per element, right? And then what the report would do is it goes, this element number 1, and then the 3 values, right? And it's got a label for it, and then it goes on to the next one. It's got a different label for that one, and so on and so forth. The ChatGPT didn't even fucking bother with anything other than the headers. Didn't even fucking bother. And then there's a bunch of code that prints out the actual check, right? So we print out checks. It's a name and address up top on the top third. Middle third is like it's the remit. It's a breakout. It's detail lines, right? Item A, dollar amount. Item B, dollar amount. That kind of bullshit. And then the bottom third is the actual check. It's got the name and address on it, the spelled out dollar amount, the numerical dollar amount, like check numbers and bullshit. And at the bottom of that is the mica line. That's the funny looking numbers at the bottom that, you know, that tells the bank what account it's going from and to and all that kind of crap, right? The PLB code to do that looks like this. The A's are spacing. They are 1 pixel wide characters. Don't worry about it. It didn't even fucking try. It didn't even bother trying to do this. Didn't even fucking bother. They're spacing. You heard right. It's great. How you doing, by the way? Mispresses everything he doesn't like. Yeah, I can get behind that. Why are there multiple calc functions? And once it's too complex for the interpreter. No, this should all just be a loop. So I actually removed all this in the live code, and it's now like 5 lines of a loop that just calculates all of them. It's a summation, a total of all of them, right? So you got the build total 1, build check 1-1 plus build check 2-1 plus build check 3-1 plus 4-1, 5-1, so on and so forth, right? 24 of them. 24 elements of the first sub-element, right? And then build check taught 2. All right, same thing, but for the second element. That kind of stuff, right? So this is not live anymore. I uncommented this code to send it over to him, right? Like, and I took out the loop, right? But the code he gave back for these things are just, it was so fucking useless. And he goes, oh, but it can read this. And I'm like, yeah, okay, it parsed a date. I don't give a shit about that. And it had a comment here, do the rest of the logic for all the customers. Yeah, that right there, that logic is what I wanted to see what it would do with it. And it didn't even fucking try. I'm done. No, it's useless. I'm not even going to give it the time of day for any of this shit. No. Let me actually read through the code, understand what the fuck it's trying to do, and then rewrite that with a new paradigm in a modern language, in a modern modern programming paradigm, right? Not the COBOL/PLB way to do things from the 60s and 70s. Let's write this like code from 2024. I even told him, like, even if, by just, for sake of argument, ChatGPT could perfectly read and understand this code. It's not going to, but even if ChatGPT could understand it, and it translated it to perfect Python or perfect Go, just for the sake of argument, I still don't want it, because that is going to be PLB written in Go, PLB written in Python. It's the wrong way to do it. Okay, now refactor it. Yeah. So we're talking AI. Yeah, the AI bullshit. And I just want to know. No, absolutely not. Who uses AS spacing? So this is a specific font. A squared. This is the microfont. This stuff right here, right? It's really just the numbers, actually. So the letters aren't actually part of the marker stuff. Like this isn't. No, that's no. Only the numbers and some characters are part of the font. This right here. This is the entire font. Everything else doesn't exist. Everything else. And these like start at some dumbass fucking offset too. It doesn't line up with ASCII. Real programmer can write Fortran code in any language. Yeah, right. Oh goodness, if he's damn. Literal punch cards. No, banks still use this shit, so we've got to still use it. And that A character is, so this is all a bitmap font, by the way. The font that we're using for this specific application is a bitmap font. Yes, I know that there are TTF and OTF versions of this font. For this specific one, we're not using those because, again, shut up. But in order to get it spaced out correctly, so it's scanned correctly, every character at 300 DPI is half a pixel too narrow. So every 2 characters, we insert a row of a column of pixels, so then the next character is back in line. Don't let me go paper tape. Don't do that. Can I check the great video that explains modern AI plus 17-layer web stack code disaster? Where the devs will dance with money, dance. No, what is this? What is this? Funny car engine explodes. Is this what you mentioned, Link? After this, we know what it will do? Oh, yeah. Is that only in that channel? God, Bluey. Cool. Boom. Kablooey. Yeah. AI plus modern website. They dance. So I am vehemently against using AI at work. Let it play? Okay. Vehemently against it. Did I not see the dev? The what? The dev. What do you mean? Dev will dance and go. This is all normal. Oh, the driver? Okay. But so during the same call, call about the AI bullshit, this Friday meeting, it's like a weekly meeting thing or whatever, right? So we've got multiple branches. I'm up in New England. We've got one in New York, one in Florida. He had mentioned, my boss had mentioned, the website dev will dance when all of it goes to shit. Yeah. So he mentioned that the C# code that we have in Florida is 32-bit, and they're using AI, or going to use AI, to convert that to 64-bit. And I went, stop, right the fuck there. No. If what you're saying is accurate, going to 64-bit, unless they've done something brain dead stupid, is a fucking switch. It's C#. It's .NET code. It's .NET. The target is it's a drop-down selection. That's all it is. If you need AI to tell you to change a drop-down, you're doing something very wrong. No, Windows Shop. Not Mono. It's a Windows Shop. I even told him. So there's a this thing. Yeah. This right here. This is my EverDrive. It's a ROM cart, right? It's got a USB port on the top of it, and it has a program written in .NET to talk to this. That program, it's like send like firmware updates and ROMs and kind of shit to this while it's running, which is kind of neat. It's got a little program to do that, written in C#, written on Windows for Windows. I was able to upgrade that to .NET 8. I forget what it was originally written in, but I was able to upgrade it to .NET 8 with no issues on Linux for something that it wasn't even designed to run necessarily on Linux. It just fucking worked. I'm like, if I can do that easily, why the fuck do they need AI? Like, what are they doing wrong? Something's gone wrong. Something's gone very wrong. So stop, take a step back. What the fuck are they doing wrong? I want to know. I want to know how they work. When I converted my C code from 32 to 64-bit, it was just a target change because I was using types that already specified their bit widths. Right. So what I can see happening is they were doing some stupid shit with some libraries. Some really dumb shit. That's what I think was going on. And that's the hard case Boolean. So I want to know specifically why they need AI for this shit. Because my boss, he's not a programmer. He's not. So he sees ChatGPT. And he's like, oh, we can totally use this for code stuff. He doesn't realize that it will just make a fucking mess. He doesn't realize that. Is this still going? That's still going. And I want to get in there and be like, no, stop it. You're gonna regret this. Stop it. Absolutely not. Do not use this. You will regret it. Maybe not tomorrow, maybe not next week, maybe not next month, but you will look at this code and regret it. Or if not you, whoever has to work on it next. It still only needs to have at least 16 bits even today. But so we don't use C code. We don't use C++ code. It's C# code in Florida anyway. So it's not C. So like they're on the .NET framework. Oh, well, they're on the .NET ecosystem. Cuz I don't it might be .NET framework. I don't know. Maybe that's what it is. They need us convert from .NET framework to .NET Core. I still wouldn't use AI for that. No, fuck off. No, that's disgusting. Why would you even think that? Oh, but it's hard. Yeah, life's hard. Life's a bitch. If it wasn't hard, life would be a whore. I guess you didn't see. I hate the term AI when in game dev, because in games it can now mean game AI or ML style AI. Yeah. I don't. Yeah. I hate the fact that like ChatGPT and friends has taken over the AI abbreviation meaning. Yeah. It's even specific to ChatGPT. Forever, there's been commercial transitions for legacy language, and they always end up with unmaintainable code. Yeah. So what I'm trying to do at my location anyway is I have a process of a thing. I'm going to look at that whole process, and I'm not going to translate that old code into new code. No. Instead, I'm going to look at the inputs and the output. And I'm going to re-implement that from scratch, from start to finish. Period. If I have questions of why the input is this, I'll look at the old source to figure out what it's actually doing with that value to get that output, right? So yeah, there's like two different things right now that I'm working through to convert old code into something new. And that's the way I'm doing it. I'm not doing AI because it's an entire paradigm shift, right? This one application is using VIP code, right? See if I can get any examples of this. It's this shit. It's of course there's no fucking. Anyway, it's basically PostScript with a fuckload of macros. That's what it basically is, right? It's all specific to Xerox. But this PLB code spits this crap out, and then a different Xerox application, or a Xerox application rather, takes that VIP code and transforms it into PDF. Sometimes, because we can actually send that directly to the printers. They're Xerox printers, and the printers can read that directly. So I'm taking that legacy code. It's all written in PLB. This outputs VIP. It's a very simple program. Simplex or one-sided checks, only checks every page, one page per item. Every single page is just checked, right? So nothing's different, no trade calls or any kind of bullshit. So I'm taking that from the PLB bullshit, and I'm converting it to Go. And I've got most of that program done, but there's a lot of like little things here and there I need to figure out that aren't like specific to that one program. Things like the NCOA, National Change of Address, right? You move, you tell the post office that you moved, so when someone sends mail to your old address, it gets forwarded to your new address. That's what NCOA is. All of our programs use that. So that's a standard thing that all our programs will use. So I need to figure out a way to interface with that uniformly. Put it into like a library, essentially, right? Same thing with all the generic postal bullshit. And I've been rewriting our postal sleeper is what they call it, because it sleeps. I hate it. The postal program that coordinates these different postal soft programs to like fix up addresses and sort addresses and make a bunch of barcodes and all kind of bullshit. So I'm rewriting that program, and I'm doing it from scratch because I'm doing it as if it were a program written in 2024, because it is, right? So I'm not using the old methods of like, write a file here, and then copy this file over there, and copy this file over there, and then copy this file over here, and then scan this file for this crap, and then replace this line with this line, and copy this file over here, and then based on the file name, we're gonna do this, and then no, fuck off with all that shit. I'm doing it a better way because go to hell. It's almost done. I just need to do some glue stuff around it. But ChatGPT won't be able to do that. ChatGPT would not even understand that it's shit code that needs to be rewritten from scratch completely differently. It would have just translated that code into Go code that is equally unintelligible. Right? Now. AI and can be used for anything if what fucking world is that? In what, yeah. PostScript is a Turing-complete language in Wii, bunch of geeks, bork the new Apple laser printers back in 1989 by tossing computational code at them over FTP ports. Just geeks being geeks. PostScript is fascinating. It's a fascinating language, yeah. And so for a lot of this stuff, I've debated, like, all right, do I want to take this DJDE code, which is an older Xerox format? I go, do I want to take that and make a converter that reads the DJDE code and the configurations and all that bullshit and spits out raw PostScript? Do I want a raw dog PostScript? I don't know, maybe. That's still kind of on the table, right? Like that hasn't been completely pushed off the side yet. That might be a possibility of something I do. Maybe. I don't know. We'll see. Depends. I think that's always bad. Copy and paste the C++ compile warning message into it and see what it spits out. Oh, God. Friend computer knows nothing. Was the name Jon Snow? You know nothing, Jon Snow. That's the point. ChatGPT can't know what to do. It doesn't think. It doesn't know. Anyone who claims otherwise is wrong. Right. Just replicating what it saw. Right. So I actually saw 2 articles over the weekend. last weekend. I think I posted one of them in Discord. But one of them was like they pointed out like the training data isn't training, it's building. It's creating the model. At the end of the training, the model is now static. The model doesn't change. No new data is added to the training data to update the model. The model's done. It doesn't learn. I trained out data. Trained data without permission. Might call it trained on data. Might call it still in data. All right. It's a fancy Markov chain token predictor. Not word or letter, but predefined stuff. Yeah, it's probabilities all the way down, basically. Right. That's all it is. It's very complex probabilities, which is fascinating. Don't get me wrong. It's neat tech, but it's tech in search of a problem. Right. It's a solution in search of a problem. For a lot of it. Yeah. Really need to do a ghost stream someday. We'll both need sedatives. Yeah. Well. It's tech in search for power generation. Yeah. Right. Oh yeah, Dennis. By the way, I'll not next week, but the week after. I've got a wedding to be at. Up in Canada. Unfortunately, it's a very short visit. Otherwise, I'd see if I could meet up with you. But I'm going to be up there for in Ottawa. But it's like I'm going to be up there for like a day and a half, 2 days tops, and then I need to get the fuck out. So okay. So the next 2 weeks. Next week, I'm not going to be streaming at all. Next weekend. My mother's birthday and Father's Day. All in one weekend. I'm not streaming. The weekend after, I'm getting in a car on Friday. And with my friend that's getting married, I'm driving to Ottawa from New England. 7 to 8-ish hours, depending on traffic. Saturday's the whole wedding thing. Sunday morning, I hop on a plane back to Boston so I can attend my cousin's wedding that afternoon. Is it the Chateau Le Four? I went to someplace cheap where I could use my miles. I'm not going to be in the hotel for anything other than sleeping, so I wasn't too worried about it. Yeah, here's hoping there's no flight problems. Yeah, that's the only thing I'm nervous about. Is the flight back. It's an hour-and-a-half flight from Ottawa to Boston. But if something gets delayed, I'm fucked. So I land at like 11 or something like that, right? The wedding's at 5-ish. So I have time to get to where I need to go and change and all that kind of bullshit. As long as everything goes smoothly. So we'll see what happens. I don't know. My friend initially asked if I was going to go to the wedding, thinking, oh, it's in Ottawa. He probably doesn't want to go all the way up there. He'll probably say no. My response was, no. So help me God, I will be there. I will make it a fucking point to be there. So help me God. He's like, what? No, wait, this is what I had planned. Wait a minute, shit. Time for a thesis? Yeah, sure, why not? But so that's why I'm not streaming the next 2 weekends. For some obscure reason, you'll be in Ottawa for a day in July. Yes. No, in 2 weekends. So like the 22nd. But I'll be busy the entire time. Yeah. This is around for the week. Looked into where the hell is the stack in memory? Need to access the variables in memory for the JIT compiler. Turns out the stack, A, is a heap, and B, it's located somewhere and a memory file, persistent memory and shit. And the offset is complex. To quote my professor, this really turns out more complex than I imagined. Yeah, thanks for that. Could have been there. If I wasn't gonna be up there for a wedding and need to be back the next day, I absolutely would have. I would have figured something out. But I've got so little time for this, that unfortunately I won't be able to meet up. I want to, but I won't be able to, unfortunately. I'm sorry. I'm sorry. But yeah, so we're going up Friday. Friday night, there's already like some bachelor party stuff, shenanigans that I'm gonna be involved in. Saturday, like during the day, is the actual ceremony. Night is like a after party kind of thing that starts like 7. And then the next morning, I need to get the fuck out of there. I need to get to the airport ASAP, so I can make the next wedding. Also gotta love the Jen Sun Hong, NVIDIA CEO. Okay, is the uncle of the AMD CEO. What? That sounds like a conflict of interest. Oh my god. Related somehow, but now you got two cousins in charge of the 2 big GPU companies. Yeah, that sounds bad. Yeah. Looking to stack is simple. Declare a heap variable and grab the pointer to it. Then, when trying to use it, use that usefully to look up other things on the stack. Good luck, and sorry about the bald spots from pulling out your hair. Well, so he's writing, I think a VM for something, right? For Smalltalk, right? Is that right, Captain Pie? Please take a moment and explain to people what VM hat is. Virtual memory to hardware address translation. The real memory is behind a VM hat layer, and pages are tracked in real memory someplace else. Just to explain virtual memory, it's what we are mostly using these days, not real memory, right? On the NES here, I'm using real memory, but this is like a system from the fucking 80s, so, you know. No, I don't want that. This here. This is all real memory, but this is an 8-bit system. The scroll bug is here too. Oh my god. Before NVIDIA worked at AMD. Oh my god. How is that not a conflict of interest? JIT compiler for Smalltalk. The VM is already there, and god, I hate the code base. Oh. Now. Well, you did this to yourself, though, didn't you, Captain Pie? Like, you chose this, didn't you? I think you chose this. That was in 93. Leo only became CEO of AMD on the Zen days. I don't know, this still sounds like a fucking conflict of interest to me. This is still going, goddamn. How long is it supposed to run for, Dennis? No, I need to do one of these. It's just pinning a processor. It's just pinning a core. That code, yeah. At, what was it? What do you have me run it at? 85? He did. Okay, I'm gonna cancel that. Let's play the is the function declared in the header file or the C++ file lottery. You didn't let it run. What do you mean? You said it was going to end at the heat death of the universe. I don't have that kind of time. Try a smaller number. Well, I did 55 before. That was this one. 60. 70. 65. Down the directly related, Sue's maternal grandfather is the eldest brother of Hong's mother. It works. Yeah, I meant the number you had me run before. Was it just proving someone in chat wrong? I'm all for that, by the way. Try 80 or 85 with the exponential S curve, 3 curve will bite you. Yeah, noticed. Anyway, what was I? What was I doing? I don't remember what I was doing at this point. Yeah, I kind of did that to myself. Yeah. Not that I had any real options other than look for some of the language that needs a JIT. Someone is wrong on the internet. To arms! We've got to correct them, damn it. I think I've seen that scroll bug in most scrollable areas. Yeah, I suspect it's the bug in the scroll bar or scroll plane or whatever, which is common to all of them. Yeah, so someone actually brought that up to Sour a fucking week or so ago, 2 weeks ago. And as soon as someone brought it up, everyone else was like, oh yeah, that bug. Oh yeah, that bug. Oh yeah, that bug. And Sour's like, wait a minute, hold on. You all knew about this bug but didn't tell me? What are you doing? Did you just assume that someone else reported it? And then I looked in the previous stream at that point that I had done, and I was able to find an instance of where it happened. Here, it is timestamped. Here you go, Sour. He's like, what the fuck is this? It was quick hack code to explain to someone. Someone was wrong on the internet. Yeah, that the math can get ugly real fast. Gotcha. All right. Should have made a siege. Get out of here. Get out of here. I feel like I've never been paying attention when you got the bug, because what is it exactly? So, I'll have something like I'll have code running, right? Code will run. I'll get a breakpoint. I won't click in the window. Let's see if it does it. I don't think it'll do it. I won't click in the window, but I will scroll on the mouse wheel and it'll jump like somewhere random. Let's see if it does it. Oh, it didn't do it this time. Okay, cool. But yeah, it'll jump to like down here or something like that, right? Or like down there or something stupid. It just scrolls to some unrelated place, right? And here, I was looking at code roughly over here. It scrolled up to like hex 6000. It scrolled to here. Right? I don't know steps to trigger it consistently. So I don't know. I don't know how to trigger it consistently to track down why it's happening. You know, kitchen is a mess. Must move along before it bursts into flames. No worries, no worries. But yeah. Anytime you see me like, anytime you see code that I have where I'm at a breakpoint like this, and then I scroll, and suddenly that breakpoint isn't in view anymore, the bug just happened. Yeah, intermittent, which is the worst kind. Oh god, yeah. Yep. Actually, so wasn't there like a bug in the Linux kernel at one point that was an intermittent bug that like no one really knew how it triggered, right? Which was fine because like the fix was, oh, just reboot. It was during the startup process, so if it broke, just fucking reboot, whatever. But the chance of it happening were low enough that no one really cared, right? Until someone came along that cared. He's like, hey, so this is part of automation shit, and like this breaks automation like 1% of the time, which is too much because we're deploying this many VMs, and it's a lot of VMs, so that translates into like hundreds of fails like every other day or something like that, right? He's like, we need to find this. I need to find this bug. So he spent like a fucking month tracking this shit down, and he eventually found like this obscure piece of code that just had a chance to break. God, what was that? obscure. I don't know if I'm gonna find it. Was it this? Hang on. Let me see. Ah, okay. Yeah. I think it was this. Maybe it wasn't kernel. This right here. Uncovering a 24-year-old bug in the Linux kernel. Oh yeah, in the Linux kernel right there. So doing a bunch of let me copy paste this. In case you guys want to read it. Yeah, so snapshots of ZFS snapshots and 600 gigs and 200 gigs and all that kind of stuff. Using rsync. One of the most interesting issues we encountered led to the discovery of a fairly old bug in the Linux kernel TCP implementation. Every now and then, an rsync transfer from a source server would hang indefinitely for no apparent reason. As, apart from the stuck transfer, everything else seemed to be in order. What's more, for reasons that become apparent later, the issue could not be reproduced at will. Although some actions, e.g. adding an rsync level rate limit, seem to make the issue less frequent, with frequency ranging from once or twice per week to once every 3 months. As is not unusual in these cases, we had more urgent systems and issues to attend to, so we labeled this as a race condition in rsync that we should definitely look into at some point, and worked around it by throttling the rsync transfers. Until it started biting us every single day. Right? How long is this? Bonus points on that interpreter code base. Some function calls have a random -1 on their arguments. Turns out that -1 is necessary for every single function call. And no, instead of subtracting 1 in the function, it's done by the caller. Also, same function has incredibly illogical code. The edge case is 128, but the check is var less than 127, so the normal person would think, hey, what's with 127? The argument is decremented once in the assignment at the end of the line. No, oh my god. Oh my god. Wow. Until started having it every single day. But yeah, so good read about how they found the bug in the pipeline in the TCP stack or implementation. I'm not going to read through all this right now though, but yeah, it's a good read. It's a good read. Back up to dinner. Nice. We're talking about Windows now. No, so that was a TCP window. TCP window. The window is stuck closed. Now it's time to delve a couple layers deeper and use TCP dump to see what's going on the network level. TCP windows, yeah. But no, yeah, kind of. Yeah, I pasted the link to the article. I'm not going to read through it, but that's the article there. This guy basically discovered a 24-year-old bug in the Linux kernel. At first, it wasn't too bad, right? Using a pipeline to move ZFS snapshots around, size of 600, 200 gigs, give or take. But yeah. Every now and then, an RC transfer from a source server would hang indefinitely for no apparent reason. Everything else looked fine. It's not unusual. In these cases, we had more... it seemed... Hang on. Although some actions, adding our single rate limit, seem to make the issue less frequent, with frequency ranging from once or twice per week to once every 3 months. They said, we'll put it on a back burner. And then it started happening every single day. That's no longer a back burner. That is front and center. So they needed to figure out why it broke and fix it. So they did. They figured out why it broke and they fixed it. But yeah, it's a good read. It's a good read. All right. Anyway, where the hell was I with this? What was I doing? Make. Over to this one. Yeah. Shit. Call FN jump. I don't like that. Help topics. Effects list. BXX jump. We're using title screen. Those are D's. B isn't in here. Hold up. Jump to frame order XX. Wait a minute. Here's getting someone to look into something like that. It breaks your stuff badly, or 2. Your program is 0.5 seconds slower. Yeah. Okay, what? I'm not convinced that this is looking at the right data. What's the pointer I need to look at for this? I have something in data, right? Data 87. There's a jump table. Pointer FN, command functions, sure, data is 87. That's the command. Okay. Where is data? Stored. Pointer frame FF. Uh-oh. That ain't right. Pointer frame FF. Channel, instrument. Channel state frames. Okay, what is the channel ID currently? CHID 3, so that's noise. Wish we could worry about a performance of 0.5 seconds. Yeah. Game dev. 0.5 seconds is basically a nuke going off next to your window. Yeah. I was actually talking to one of my coworkers the other day about like efficiency and coding efficiency or whatever, the efficiency of code. This is a retiree, and I'm like, I don't really need to worry about that because we're going from PLB to literally anything newer will be so much faster. So don't worry about it. Like you're worrying too much. This is the same guy, by the way, that like asked if we could not use pointers in Go. I'm like, what the fuck you on about? Because he said it like he was offending me or something like that. Because he was scared of like dangling pointers and shit, and I'm like, you're thinking of C. Stop it. Everything you know about C pointers, that's not how they're done in Go. Stop it. And he found like these like articles that outlined like really obscure fucking edge cases in Go for things, doing shit that you just should not be doing first and foremost. And he's using that as like, oh, but we shouldn't. I don't know. I'm not comfortable with this. I'm like, you'll never hit this. I haven't hit this in the 7-ish years I've been writing in Go. If you hit that, you're doing it wrong. like, if that right there is actually the source of a bug, you've got bigger problems. But yeah, you're comfortable with PLB, right? Yeah. So I told him, like, that article, ignore it. Everything you read in that article, forget about it. You will not hit that issue. Just forget about it. You're doing some weird shit you shouldn't be doing. Stop it. Go pointers just references. Yeah, exactly. Like, it's pointers are used fucking everywhere in Go. And it's nothing to be scared of. But he thought of, you know, C pointers and got scared there. Also, what's with the gray blob on that CH? Huh? What do you mean? Gray blob on CH. What are you talking about? Oh, you mean this right here? That's the current selection. The GX, no delay? What do you mean? I'm not saying what you're saying. The GC will not track pointers to unmanaged resources, but that's so niche. He's making up reasons. Exactly, he's making up reasons. Green screen? Oh, oh yeah, that right there. Yeah. Or no, that's not even the green. That's a spot on my fucking teleprompter, isn't it? God damn it. Son of a bitch. I'll clean that later, I guess. I can't even see it from here. I don't know. Maybe deal with the fear of the unknown. Everyone does it in one way or another. Yeah, I guess. But I told him, like, the only spot where you'll get weird shit with pointers is dealing with the Windows API. So don't. Just don't. You just don't be doing shit with the Windows API. Everything we're doing here at this company will not be working directly with the Windows API. So don't. It's just as simple as that. For everything that we would need an API call for, there's Go standard library stuff for that. Like, open a file. Import the OS library. os.open. There you go, it's open. You don't gotta worry about anything else. There's another spot using the unsafe package to mainly use real pointers. Well, yeah, the API stuff uses real pointers for that. Because it's gotta pass around real, like, window handlers and shit. Now, you know the fact that it's unsafe. Yeah. Yeah, the unsafe package. Just ignore unsafe and be paranoid with that. No. It's hard to do bad shit with Go either by using unsafe or using stupid APIs. Yeah, exactly. It's like the dumb shit you'll be doing is like reading a file. Inefficiently. Is it gonna break everything? No. Is it stupid? Probably what you're doing is dumb. But, like, you'll live. The program won't crash. It won't kill the server. Unless you're doing something very wrong. But, like, you know, you have to try pretty hard. Even on unsafe stuff, as long as you're just storing a pointer ID, it should be fine. Yeah. And like, even, like, okay, say you do something stupid, right? Assigning to a nil mapper or something like that, right? It happens to me all the time. Well, not all the time, but frequently enough. Run the program, it crashes. Oh, God, oh, no. Stop it. There's a stack trace. It's not like function addresses. It gives you the source file and line number of the thing. Take a breath. Look at the file. Look at that line in the source. And fix it. It tells you exactly where it went wrong. It tells you how it got there. Yeah, you don't need a bus.gdb. We should use Go and Rockets, right? Run the program, it crashes. And then it crashes. No, there was that one talk, or I don't know about talk, but yeah, it wasn't a talk. It was a anecdote This guy was reviewing code for a missile system, right? It was C code or whatever, and he's doing like a code review kind of thing on it, right? He's like, hey, there's a memory leak here. You guys should probably like fix that. And they're like, oh, that. Yeah, we know about that. It'd be too hard to fix the right way. So we're doing it a different way. And you're like, what the fuck is a different way? Because, okay, so we figured out where it was, where this leak was. And we calculated how fast it happened, right? And this is all code for a missile. So we calculated how long the missile has, like fuel-wise, right, to get to its target. And then we calculated how much memory would leak in that amount of time. And then we doubled it. And we put that much memory in it. We don't need to worry about cleanup, because when the program is done, it blows up. So it's not our problem anymore. It's fine. The ultimate garbage collection. Blow the computer up. Thank you for the follow. Appreciate that. Do you have any advice for Commodore? How you doing? For dreading violating your intuition? What? I think it's my biggest barrier in learning to code. Let me turn that. That's a little loud. That feels a little loud. Intangibles violate my association with intellectual disciplines. Hard science is cool. There's no belief in magic, unlike the evolution deniers. An algebra and code is the biggest kick in the pants into that association. Wizard, how you doing? Wizard of Datums. Learning the basics, and I don't mean the easy stuff. What really helped me is going down to the bare metal. That way I really understood why magic is doing what it did. Yeah, so I don't know who originally said this, but any sufficiently advanced technology is magic, right? For me, before I started my journey into assembly, I saw assembly and went, wow, that's black magic. That's the dark arts right there. I don't have my summoning circle to play around with that, so I better avoid it. Right? Until I started actually like diving into it. I'm like, oh, this isn't that bad. It's just very verbose. And the fact that it's so verbose helps me actually understand certain things. Like, I have a much better grasp of what the fuck a pointer is because of it, right? Much better grasp. Like when I originally wrote this audio code, right? The reason it used those macros with the fucking assemble time concatenation of strings for variable names. The reason it had those was because I didn't fully understand pointers, and they scared me. But after coding in assembly enough, I started using them and understanding what they were used for and how they were used. And now I understand pointers a lot better in higher level languages. You know? So assembly is no longer like black magic to me. It's just it's just very verbose. Arthur C. Clarke. Was that who it was? Ronnie Holm, how you doing, by the way? Welcome. I'm not sure if I said hi to you yet. Whenever you're learning something new, a large part is calibrating your intuition. Other people pointing to the NASA coding guidelines. Maybe everything doesn't need to be on the standards of keeping people alive in space. Yeah. So yeah, it doesn't. Not everything needs to be held to those standards. You know. The link I posted is that story. Oh, okay. Come on, scripts. An amusing story about a practical use of the null garbage collector. Some time ago, I noted that the null garbage collector is a valid garbage collector, and if the amount of RAM available to the runtime is greater than the total memory requirements of the program. This insight lets us make some statements about what you can assume from garbage collected languages. But it also can be looked at as rules for deciding when you can simply ignore the memory leaks in your program and just use a null garbage collector. Here's one developer who learned about an application for this principle. The only programs I know of with deliberate memory leaks are those whose executions are short enough, and those whose target machines have enough virtual memory space that running out of memory is not a concern. This sparked an interesting memory for me. When I was once working with a customer who was producing onboard software for a missile. In my analysis of the code, I pointed out that they had a number of problems with storage leaks. Imagine my surprise when the customer's chief software engineer said, "Of course it leaks." He went on to point out that they had calculated the amount of memory the application would leak in the total possible flight time for the missile, and then doubled that number. They added this much additional memory to the hardware to support the leaks. Since the missile will explode when it hits its target, or at the end of its flight, the ultimate in garbage collection is performed without programmer intervention. Any technology distinguishable from magic is insufficiently advanced. That's good. I associated Clarke's third law to mean tech from 1985 looks like magic to people from 1885. But a college-educated adult can have a complete understanding of a whole device. Maybe? I don't know. Isn't it insufficiently... It is. He inverted it, John Micah. He inverted it. Corollary. Corollary. I think I've heard that word before. I think. Not that I've used it in conversation, but... You know, any technology, no matter how primitive, is magic to those who don't understand it. Maybe that's why there's so many fucking, like, conspiracy theorists around, like, aliens and pyramids and shit. Because they, on a fundamental level, do not understand that stacking rocks is kind of easy. And that cutting a stone in half isn't as hard as you think it is. It's just tedious as fuck. Like, you don't need power tools for that. You don't need lasers for that. There's actually a video I posted on Discord a while back when it was released. But there's this guy, Mini Minuteman on YouTube, that, like, a big portion of his content is debunking dumbass conspiracy theories, right? And the most recent one was about this one guy and debunking, like, all of his crap, right? And this weirdo was like, you're trying to tell me that they cut stone in half with copper and sand? As he shows a video of researchers, like, recently doing exactly that, using stone and some copper, cutting limestone in half. Sure, it's tedious as hell, but it's possible. They debunked the magic bullet. I think so. How do you spell conspiracy? No, I don't know if I know exactly what you're talking about then. But they're heavy rocks, right? And all these pyramids, they're in a pyramid shape. Oh my God, all across the globe. You're trying to tell me they didn't communicate. Guys, it's a pile of rocks. That is the simplest structure you can make. Is a pile of rocks. They don't need some more intelligent being to tell them how to stack rocks. Anything got anything if accelerated enough, right? I believe the decompiler deliberately leaks everything because when the process terminates, the OS will clean up everything anyway. Unless you don't know what magic is. Magic being the stand-in for like, oh, it's God doing it or something like that, right? No. It's not if you have to carry a stone 500 plus miles, right? Also, boats exist. So, like, they didn't drag it 500 miles. They put it on a boat and sailed down the river. Now, the only tech that is simple enough to understand is obsolete, right? And the stone's weight is quite large. Yeah. Damn, Philip Zeba. Wait a minute. Is that? Hang on. That's the guy who we debunked, isn't it? Yes, it is. Philip Zeba. Yeah, debunked. Yeah. This was a 2-part video series. Part 2 is 2 hours long. Part 1 is an hour and a half. This guy's fucking fantastic, by the way. If you haven't seen any of this guy's videos, I highly recommend. Have you seen how heavy those rocks are? How can something that heavy float on water? Okay, have you, like, seen modern boats? Those are heavier than the pyramids are, I think. Certainly heavier than the individual rocks. And there's a lot of those floating right now, actually. But those are modern and metal and shit. Well, it's just the smooth brain. I can't. They didn't have steel back. They didn't have lasers. one of the points he brings up in this episode right here is like, they didn't have lasers to cut the rocks. And Milo, that's the other guy. Milo, he's like, yeah, they didn't have lasers when we went to the moon either, but we did it then. Like, what do you want about? Like, computers happened before lasers. Huh? Whatever floats your boat. Whatever floats your boat. You mean buoyancy? Yeah, that. My standard is that the moon landing was faked from a movie set on Mars. Same way things fly in air. Yeah, right? Recently, they discovered evidence of a previously unknown branch of the Nile that happened to be, guess where? Next to the pyramids, right? Yeah. Yeah. So, like, it's very plausible that the base around the pyramids before they were built was literally flooded so they could just float the rocks in. Holograms happened before lasers. Can't build ships that large. 1917, that's a big ship. Launched in 1909. Go ahead with your science. What's next? Telling me gravity exists? Gravity's fucking weird, honestly. So, a few years back, by the way, I went down a fucking rabbit hole, right? So I forget exactly what video I was watching, but it had mentioned spinning black holes versus non-spinning black holes. And I'm like, okay, hold on. What the fuck you on about? What is this? Excuse me? I'm gonna look up some videos and shit on black holes and spinning black holes. What then proceeded was like a month or two or more of me falling down the rabbit hole of, but what the fuck is gravity actually? We don't fucking know. Kind of. It's kind of like this, but it's this and science theory. Yeah. So I know more about like black holes now, and shit's fucking weird. So Hawking's comment at one point that black holes don't exist, they can't, kind of thing, right? Or was like the singularity can't exist, right? And everyone's like, you're talking nonsense. But then, like, after watching all this shit, I'm like, oh, I think I know what he meant. So, when you cross the event horizon of a black hole, right, time goes kind of fucky. Time and space kind of, like, switch places a little bit. So it's a little weird. A little weird what happens. So time, like, dilates and slows down the closer you get to the singularity. So I'm like, wait a minute, hang on. Slows down as you get closer. The singularity doesn't exist yet. Because it's still collapsing, technically. Is that what it is? I don't know, maybe. I'm probably talking to my ass. I think I am. But I'm like, is that what he meant? I don't know. Maybe that's why we don't see any bare singularities anywhere. Because none of them actually exist yet. I don't fucking know, though. I don't know. I mean, physics doesn't exist at the singularity of a black hole. Right. Like, everything that we understand about physics and quantum physics kind of goes out the fucking window when you get to the center of a black hole. It just goes, never mind. Do we just approach zero for infinity? I mean, fucking, I don't know. Maybe. The black hole information. Yeah, there's another that. Yeah, the information paradox. Paradox that appears when predictions of quantum mechanics and general relativity are combined. The theory of general relativity predicts the existence of black holes that are regions in space-time from which nothing, not even light, can escape. Right. In the 70s, Stephen Hawking applied the semi-classical approach of quantum field theory in a curved space-time to such systems and found that an isolated black hole would emit a form of radiation, now called Hawking radiation, in his honor. Yep. He also argued that the detailed form of the radiation will be independent of the initial state of the black hole and depend only on its mass, electric charge, and angular momentum. Yeah. The information paradox appears when one considers a process in which a black hole is formed through a physical process and then evaporates away entirely through Hawking radiation. Hawking's calculations suggest that the final state of the radiation would retain information only about the total mass, electric charge, and angular momentum of the initial state. Since many different states can have the same mass, charge, and angular momentum, this suggests that many initial physical states that could evolve into the same final state. Yeah. Therefore, information about the details of the initial state would be permanently lost. However, this violates a core precept of both classical and quantum physics, that in principle, the state of a system at one point in time should determine the state in any other time, at any other time. Information should never be lost. Hello from Brazil. Hello, how you doing? Welcome. Bajinho, am I saying that right? Probably not, but welcome. I think there being a singularity in there is being used as evidence that our physics theories are wrong. I mean, maybe. I don't know. I like the cosmic censorship hypothesis. You can't find a naked singularity because that would be obscene. Also, that like every black hole spins because fuck you. There's always going to be an initial parameter of like the spin, right? So it's always going to spin, which means that like a non-spinning black hole, all that stuff, doesn't really apply practically necessarily to all the black holes that we observe because all those are spinning. They all spin. And things kind of go a little fucky with singularities and spinning black holes because they're more of like a ring, I think, right? They all spin in the same direction. I don't think so. No. It all depends on the event that created them. So if you take a star and turn it into a black hole. That star was spinning in a direction. Just because of like the motion to get that star created in the first place. There's going to be variations in all the matter that clamps down on it, and it's not necessarily going to be even, right? So it's going to have a spin on it, even if it's very minor. It's going to have a spin. But when you take all that mass and squish it down to really small, that speeds up. You know, think of the analogy that's always used is an ice skater that spins, and they bring their arms in and they spin faster. Yeah. Also, there's a theory about a hypothetical planet, which is between Mars and Jupiter, but it got kicked out. Oh. 120 years ago, Newton's math wasn't enough to predict Mercury's orbit. People thought there was a planet before Mercury being fucked with the math. Fucking with the math that we named after the Greek god Fire, Vulcan. Yeah. Planet V, Vulcan. Is that the one you're thinking of, Jamaica? The 9 sign updated the math. Yeah. Once exists between Mars and the... Oh, this is something different. Okay. In their hypothesis, the late heavy bombardment of the Hadean era began after the that word. I know what it means, but I can't pronounce it. From the other terrestrial planets caused Planet V's orbit to cross into the asteroid belt. Chambers and Lesueur. I don't know. Present the results in just a test and hypothesis during the 33rd Lunar and Planetary Science Conference held in March of 2002. Oh, neat. Hey. Huh. But, yeah. Astrophysics is fucking fascinating, honestly. You know? It's really fascinating. But what I was getting at, I guess, is that apparently gravity might just be, like, a side effect of, like, space-time and gravity? Or space-time and curved space-time? It's just a side effect of that, kind of, because shut up. I don't know. Maybe. Who knows? I don't fucking know. That's for sure. But yeah, very interesting shit, but way over my head, or a lot of it's over my head. Oh, the break again, right. Data 87. Okay, where did this data 87 come from? Gravity just the curvature of space-time, as far as I know, which is affected by the presence of mass. Right. So gravity isn't necessarily a force, it's a side effect. I think, or something. I don't know. I'm partial to the idea that all energy is mass in relation to mass. Sure. Got another fun fact. There's a chance you got an antimatter generator in your kitchen. And it's always the same weird thing in your kitchen. Bananas. Of course. Of course. Of course it's fucking bananas. Okay, so I need... Alright, where the fuck does this data actually come from? Store data. Pointer frame. PTR frame. Okay. At Y. Y is clobbered. Oh, boy. Pointer frame is at FFF. What the fuck? Is that in this process channel? It is. Where is that store? That. All right, the first one. Pointer data. Pointer frame. 8647. Okay. Thank you for the follow. Appreciate that. I don't know why my alerts broke suddenly, but... Am I underflowing? I don't know. I'm not doing something right. If I understand it right, matter is just blobs of energy that is pretending really hard to be solid, basically. Twitch is recommending a Pinball World Championship. Didn't know they exist. They absolutely do. Yeah. I know someone in another community that is very big into the pinball stuff. Into the yeah, all the championships and the events and all that kind of stuff. Okay, so this actually runs for a few frames and doesn't like shit itself. Channel ID 0. Okay, next channel ID. It's also 0. Now it's 1. Oh, because loading up a fucking instrument, essentially, right? All right, let's actually have a look at what this data is. Right there. Frame list pulse B 0. All right. Song 0 frame list pulse B 0. Okay. So let's open that up. Song 0 frame list. What did I say it was? Frame list pulse B0. This guy here. Command instrument 10. Okay. 94 and A is 10. Okay. So we're loading up an instrument. Liquid Y, next frame data offset. Transfer Y to A. Load Y. Pointer channel at that. Store the data. Wait a minute. Let me follow along over here. Read the data, store it in data, increment, next frame data offset, transfer Y to A, fix me. Load Y, the read offset, store that into channel. Okay, yep, all right. That's the read offset. Okay. For the next read. Fair. 1. Yes, okay. Load data, branch minus. It is negative, so we're doing a command. Load A0, bit data, BVC, overflow, clear, command lookup. Okay. Load it, and it, 14. Index to offset, 28. Functions. Pointer function, yep, sure. And then we're going to jump over there. Instrument, cool. Increment Y. Is that correct? Do command, where is it? Down here somewhere. Do command. I mean, yeah, okay. I don't clobber Y or touch Y. Get argument. Thank you for the follow, by the way. Appreciate that. Subatomic level, yes. I'm still not convinced that de Broglie is wrong. I'll admit I'm at best a layman regarding physics. Same, especially advanced physics. So it wouldn't surprise me if I'm wrong about that, a lot of stuff. Same. Never assuming you're correct. There is always a chance you might be wrong, even in subjects you are an expert in. No expert in a field would claim to know everything. Yes, no expert in a field would ever claim to know everything. I do not know everything at work. Good God, I don't. There's so much shit I don't know. But then I turn around and talk to some other people at work, and holy balls, they just refuse to learn. And I'm like, you gotta be kidding me, what? You've been in this job for 20 years. What do you mean you don't know? No. So much time and effort waits because Maxwell had a failure of imagination and nobody called him out for it. Except for experts in optics, historically. Is pointer frame right there, or should it be pointer frame? Good question, actually. Good question. Because one of them is to the data, and the other one is to the metadata, the structure, right? Process channel. Oh. Frameless points to the frame data. You know what? I think that actually is wrong. Yeah, that's pointing to fuck all. Okay. I need my eyes checked too. All right, let's try this again. We go down to the command, look up, yep, and then go to the function. Yep, instrument, good. 14. Did I have 14 before? I don't think I had 14 before. Let me actually go to that in memory. Ooh. No, it needs to be 16. Because 14... Finish pulse A0. I think it's this one that we're looking at, right? Frame list, pulse A0. Yep. 22. I should be loading 22 for the instrument, not 14. Hex 14, whatever, right? $20. Yeah, I should be doing 22. So that increment Y was wrong. Because I already incremented Y somewhere. Do I have a dog? No. Norwegian maggot. How you doing? Good? What do you mean good? Why? Oh. I asked how you were doing, and you responded with good. I see now. I'm doing fine, thank you. Appreciate that. I'm struggling to figure out how in-depth to make the tutorial for my game. I don't know if I can help you there. What kind of game is it? Is it something you can not have a tutorial, but be able to teach the player through gameplay? All right, so this is the Y here. Do I need to... Where do I clobber? I clobber that immediately. I store it there. Transfer Y to A. Load Y. Wait, I clobber it right there. It's always going to be read offset. Let's always read data and the next and the next thing. So data reads 2. 2 bytes. Transfer Y to A. No, we're not doing this, the read offset. That happens somewhere else. Oh my God. Hold up. Oh my God. That happens in the increments. That happens up here. Oh boy. So that was part of it. Yeah, I could Dark Souls it. Just add controller tutorials and explain nothing else. There you go. So how the hell are you doing object-oriented assembly? So I've got pointers to structures, and I am working on those pointers. So in the middle here, I've got the raw data, right? This being song data, right? So song 0 is like the intro song, whatever, right? This is a bunch of metadata, right? This is a bunch of frame lists. This up here, kind of. The frame list is, so each of these, the highlighted bit is a frame. This is the next frame down here. Each frame has notes and other commands and shit in it, right? And I've got 4 channels I'm working with. They ignore the last column here. I've got 4 channels I'm working with. All of them have notes and commands and shit, right? Always has been. Oh, yeah. So this is all constructed in a way that I can read it easily in assembly. So this song here, that's a bunch of metadata, right? Now, these raw numbers here actually mean things. This is a generated file, by the way. I didn't do this file by hand. It's generated. Data song? Song metadata right there. So that first byte, that 64, is the rows. 8 is speed. Tempo is 150. Frame length is 3. I think that's ignored, though. Then we got some pointers to the lists, the frame lists. And pointers to the orders as well. Right? So I got a list of frames, whoop, and each frame are all the notes and commands and shit, right? So command instrument 22. Am I looking at the right? I'm not even looking at the right goddamn. Oh god, right, because 16 hex, it's 16 hex, 0 to 9, A to F, then 10 to, yeah, okay. Hexadecimal, 16, that's 22 in decimal. Right, I need to like, whatever, doesn't matter. Instrument 22, instrument hex 16 all the way down, right? Note F2, it's F1. It's an off by 1. Don't worry about it. It's the octaves again. Don't worry about it. Then C2 or C3, C F C D, F C D, D sharp. Excuse me. Thank you for the follow. Appreciate that. Cohrel? Am I saying that right? What compiler? Yeah, this is the CA65 suite. Fit channel is annoying to use due to hardware issues, so it's often not used at all. Right. The sample channel. Yeah, it's a pain in the ass to use. It's possible to use it, but even released games, the only time that they use that channel is on like the title screen or something, right? Because you have to, during the frame, at specific points in the frame, write data to the audio processor, the audio core. You have to write like 5 or 6 times per frame, and it's very data intensive because you're writing that much to the frame, right? To the APU. So you have to dedicate a good chunk of time to just the sample processing. So when a game does it, it's usually only during the title screen. Is one F2 below? Isn't it that one? No, they're off by 1. Because that's F38 Pro. It's the octaves. The names on them are off by 1. I vaguely remember it. I don't remember exactly why. It's just that's what it is. So don't really worry about it too hard. But yeah, that's just the octave on it. Don't worry about it too hard. And then yeah, there's some other commands that'll happen in here. Like at the end of here is a D0, which is skip. Command skip. This guy here. Skip. And then this stuff here is actually skipped, I guess. Wait 10. That's the data's there, but you don't see it because the interface hides it because the skip is in there. Yeah. Okay, what was I looking at specifically now? Oh yeah, that increment. That increment should not have been there. And I'm going to get the data and the data plus 1, which is going to be the argument if there is one. I'm going to read it always because it doesn't really matter if I read an argument that it isn't really an argument. It doesn't matter. I'm not writing it out anywhere if I don't need it, right? Get the argument. That's just going to be no. That's going to be load a data plus 1. ASL A, transfer A to Y. And then at the end of this, jump to double increment. That is going to be correct now. And this is that object-oriented part of it, right? So each of these macros, volume, arpeggio, pitch, so on and so forth. That's these things here, right? Volume, duty, high pitch, arpeggio. This one doesn't actually have any of that stuff in there. Decay, swivel, decay, vibrato. This one's got pitch in there. Nothing in it. Kind of. Barely anything. There's an arpeggio right there. Right. So that data there, that's in there that I'm doing something with. But basically, okay, each of these has like a length. They've got the actual data for it. They've got a length, a loop, and running and all that kind of bullshit. Right. Enabled is the little check mark. So I need to copy that from the actual data, which is going to be, see, what was that? Instrument 22. So let's go to the instrument list. Instrument list. which is instrument underscore 16, 1422. Right? So these are the actual offsets into the whatevers, right? These are offsets into a list. So basically, I need to take or dereference this. So number 14. 1, 2, 3, or 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This one right here. So I dereference all this crap and read all this stuff out and store that in a different structure locally, so I don't have to look it up in this crap all the time, right? So I don't have to do like all this fucking math all the time and this math all the time. This right here. I'm not doing that every time I want to read up the next piece of data, right? So instead, I copy all the data locally, basically, right? And every macro has a loop. Every macro's got a release and a length, and it gets a pointer to the actual data, right? And stores that pointer directly to this data right here. So I don't have to keep looking up that pointer by dereferencing like 2 indexes, essentially, right? But for each of these, again, it's the same crap for every macro. So I just load up volume. We're going to volume. Get the pointer to the macro, to that macro volume, and then we're going over to the function copy macro, right? Object oriented. And uses DMA, which can cause problems like misreads, lost bytes for controller data. Yeah. From 1 to 10, 10 is finished. How complete is the game? This isn't a game. This is strictly a audio engine. That's all it is. So all the stuff that's printed on the screen that you don't really see right there, but all that crap, that's just debugging information that I'm not even updating right now because it was all wrong anyway. So I'm not even bothering with that now. So this isn't even a game. I'm building this, I'm writing this to be able to include in another ROM and just be like, hey, load a song and then play it. Right? Where I give a pointer to the song metadata, right? I give a pointer to this, or to this right here. And I just go, hey, take this and load it. Load it for me? Thanks, appreciate it. Now go play it. You play it? Thank you. And then during the NMI, or the vertical blanking, I just write the buffers and then process the engine. Right? And I don't gotta worry about anything else. So that's the idea. That's why it's in a namespace as well, by the way, is so I can just use variables that I could use variables and not have to worry about clobbering names or anything like that. Yeah. It's like a 2 or 5. What's this now? Oh, played Half-Life 2 for the first time and spent like 3 hours in Ravenholm. Because I didn't realize you could interact with a random lever. Oh, no. Oh, no. It feels to me like a game with horror elements. Oh, okay. I mean, if it makes you feel any better, so a long while ago when I was playing Return to Castle Wolfenstein. Old game. Old game, right? Like, look at them graphics. Look at them graphics. So I was playing this at a friend's house on like an Xbox, I think, right? And there's one level where I got to the very end of it and I couldn't figure out how to open the door. So I spent like a half an hour just retracing all of my steps in that level to find the switch. Eventually, at this friend's place, we had dinner or lunch or whatever the fuck. We had a meal, right? So I hit pause, had some food. Come back, go back to the door, turn to my right. Oh, look, the switch. It's right there. It's right there. How did I not see? It's the door's there. Switch is there. Why am I blind? Oh my God. It happens to me too. Don't worry about it. From one to down, how finished, how tennis finished, how completed is this? This isn't a game. Again, this is not a game. This is a sound engine. And I don't have like a percentage of completion because I'm still figuring out why shit don't work. I do have a lot of it done. Like the translation into this data here is more or less done. I do want to tweak a little bit of it here and there. But that won't change the engine. It shouldn't anyway. It's more like printing out stuff. Like there was one spot like with the instrument list, like right here, like it didn't have that new line. Yeah. Have I seen? I have not. Time for industrial scale deforestation. Oh my God. Spoils of agriculture. Oh boy. Oh, I like that. I haven't seen it. I haven't read it rather, but that looks amazing. Factorio Friday facts. Yeah, specifically this one here. I like that machine. I like that crane looking thing. I don't know how it works yet, but I already like it. I'll look at that later. Probably gonna wait for 2. Yeah, I want so much stuff in there so badly. The next time I play Factorio is probably gonna be 2.0, honestly. Just because I want the new. Give me new things. The biggest thing I'm looking forward to is the trains. Give me trains. Trains. Oh my God, trains. Give me the trains. Give me the trains and the bridges and shit. Oh my God, that's all I've ever wanted. And they're adding more shit too. Give me. I want it. Thank you for the follow. Appreciate that. Now, trains are in the game. Yes. They are currently 2-dimensional. They're going to be 2.5-dimensional. Have 2 layers to them. So you're going to have a train go over top of another train. Let's go. I want it so bad. This is the first thing I hear. It was weird. I apologize. Welcome. How was your weekend? Time for TTD Classic. Well, Transport Tycoon, right? Thank you for the follow. Appreciate that. But yeah, Factorio is a lot of fun. Let me. Can I get a list of the other CL posts? Back a little bit. I'll bring up the first one with all the train stuff. Train control things. No. So it started with this stuff, right? Just new rails and like different curves and shit, right? We're changing how these things kind of work because no reason. So they changed a bunch of like how the rails, you know, were placed and their geometry and all that kind of stuff, right? So Factorio 1, sure. Factorio 2 might not look different, but there's some slight differences in there that make it, you know, nice. And look at all these new things. Wow, isn't that great? You can do all kinds of new stuff, right? Yay. That's just the tip of the iceberg. The very next Factorio Friday Facts, the very next one was, hey, so you know trains? So you know that last one where we redid rails? Yeah, because bridges. We're doing bridges because shut up. we're bridges, we're elevated trains, because elevation. Let's go. Welcome. How you doing? Thank you for the raid. How was stream? I am distracted right now, but welcome. Because someone mentioned that I didn't read the Factorio Friday facts from last Friday. I gotta read that after stream now. I want these. I want that. I can't wait for 2.0. Can't wait for it. I love the technical details that go into to a bunch of stuff. I find it fascinating, right? Like I'll read it at work. It's beautiful because they don't just go into like the aesthetics of something. They actually go into like, okay, well here's the real reason why we had to redo the rails, because like fucking points and control points and here's the angle of things and it wasn't smooth and we didn't like it. It goes into like a lot of technical detail. Yeah. Seems tedious, but the fun level of tedious. Yeah. Yeah. Oh, the new planet? Yeah. But yeah, then so this was 337 a few months ago, right? Oh, it's just updates to Rails because no reason, and then oh yeah, these were why we had the updates to the Rails. Because trains can go over other trains now. Your stations will look different. I'm like, give me this now. I want this. Holy shit. Spoiler seems like a fun mechanic. Oh my god. So yeah, these are gonna be fun. This opens up a whole world of possibilities, and I cannot fucking wait. Oh my god, I want it so badly. I cannot wait for new levels of spaghetti. Hello, Just Discovery Channel. Welcome. How you doing? I do assembly here. I'm a little distracted with some Factorio stuff, but I do assembly here. Welcome. How you doing? How's your weekend? So many of my factories are just belt spaghetti and not that much train spaghetti. But with this, oh, I can't wait for the spaghetti. Oh, I can't wait for the spaghetti. Oh, it's gonna be fun. Oh, let's fucking go. Anyway, so for everyone that just came in from the raid, welcome. How you doing? What I am working on today, or at least when I'm not distracted, is a sound engine on the NES in assembly, and it uses objects, kind of, sorta. My stream title isn't a lie, really. It's still technically using objects, just not really. I don't access them like you would modern objects, right? Because I have to do it all in assembly by hand. Because shut up. Believe it or not, that is the more sane way of doing this than what I was doing it. I'm gonna dip. All right, Captain Pie. Thank you, jerk. Just as a reminder, Captain Pie, I'm off for like 2 weeks because of reasons. So see you in a while. But yeah, so I'm working on a sound engine. Being assembly sounds foolish, but interesting. So it's less foolish than what I was doing before. It's what I was doing before. On the engine.asm. This one here. So I can find it there, right there. There it is. I was manually kind of constructing variable names, static variable names, loading data from these, saving that data into working variables, and then turning around and saving those working variables back into the computed variable names. Why assembly and not C? C actually has overhead on this system. So I'm working on a 6502 processor for the NES. C has overhead. C has too much overhead, in my opinion. So in order to get the most out of the system, I'm writing in assembly. That's not why I started in assembly. That's a different story. But yeah, that and writing NES C is dumb C, is bad C. If you write C for the 2600, no. Oh my god. But yeah, so you do stuff that is not what you would normally write in anything modern for C. I don't really understand how C has overhead. Is how it does all the pointer stuff. Is all overhead, and it needs its own function stack, its own return stack, separate from the hardware stack. And there's things that are just designed for newer processors. Yeah, this CPU was not designed for compilers. It was designed to run handwritten assembly. I'm new to low level. No worries. No worries. So oh, I didn't mean to minimize that. The only like pointer math really, or pointer stuff on this processor is like, hey, we've got a pointer to something. Load that pointer at offset Y, right? .asm. Right, this right here is really the only useful way of doing pointers. So that Y, or using pointers, that Y is a register. It's a physical register on the processor, right? So I'm loading an offset, and then I'm looking at a pointer plus that offset, plus Y. This is the only register I can do that with. The only one. Whereas x86 has stuff built in where it's like, okay, we're going to take the pointer from this register, and we're going to add it to an offset in this register, and then some other crap, right? And do pointer math there, because it has the architecture for it. This doesn't at all. So no crazy pointer stuff like in modern CPUs. Yeah, exactly. The pointer stuff here is extremely basic, right? Yeah. So working with like two separate pointers at the same time is kind of a pain in the ass. Now I'm bank switching, yay! Yeah. Now I have the fact that like the 6502 can only look at 65,000 bytes or something like that. And half of that, what is it, like 64K? And half of that, 32K, is all you get for your cartridge. Do you do Golang on stream sometimes? Yes. In fact, the code to generate this is all in Go. This is right here. This is all for generating it. So it looks at this data right here. Looks at this, parses this out, and this is just like ASCII representation of this right here, right? That's all that really is. Pattern 1, C1, 16, C-1, 0A, same. It's the exact same thing. Just in ASCII, right? So the Go code takes this and translates it into, into this stuff here, into something that's readable, right? And it takes it takes this stuff here, the pattern data, this right there, all that gets translated into this stuff right here. These guys. This is one column. Yeah. Among other things, putting variables in stack space, which C does all the time, makes it fairly slow to access. Yes. And the fastest way to do it means you lose the use of one of the registers. Yep. Of which you have 3, including the accumulator. Yeah. So I've got 3 registers. Yeah. A does a lot of it. X, Y are index variables, registers, whatever. And getting stuff off of the stack, the hardware stack, is actually a pain in the ass. It's possible, yes, but it's a pain. It's much easier just to be like, look at this memory address. Go right there. Do I do Rust? No, I don't do Rust. You can also make people suffer by showing some PLB. Yeah, PLB being the worst COBOL, which is what I work with at my day job. I think I still got some of it here, don't I? Yeah, there's some worse COBOL right there. That's part of it. That's one statement. That's one print statement. COBOL for when your computers aren't strong enough. Yeah, right. Here's another one. This is some more PLB. It's disgusting. This PLB is not only like terrible looking, it's just wrong. It's just the wrong way to do it. This is not idiomatic at all. Maybe it was like decades ago, back in the 80s. You want to show? I'll show it. Hang on. Let me. Code pull samples vim stroke pulls. This, excuse me, this is syntactically valid PLB code. This is valid. This compiles. This runs. PLB doesn't have reserved words at all. And the namespace for labels, excuse me, data labels, variables, and code labels are different. And the namespace for both of those is also different from the actual commands. Which is why I'm doing like move if from move reset go to by if. If equals else display end if. Go to if go to is not equal to end if. Huh? This is all syntactically valid. All of it. This is the kind of shit I deal with at work, by the way. Well, not specifically like this. Some less painful shit. Yeah, I'll do this one. That's compiled. All right. This one. There it goes. So this is a Fibonacci sequence in PLB. This is less insane, but it's still kind of disgusting, you know? Yeah, this is what I do at work. This language is suffering. This language is fucking suffering. Where numbers are not a bit width, they are a character width. A digit width. So A, B, C, and X form, that is, hey, this is a number. 5, it's 5 digits. There's 5 of them. How many bits? No, 5 digits. Well, that's going to the list of languages I will not touch. Yeah. Numbers are strings. Yup. So there was actually a bug at work where okay, let me back up a little bit. The program, it was some accounting software, right? So at work, we print and mail shit, like checks and things, right? We have a customer, usually banks, that send us data. We put the data on a piece of paper, put that piece of paper into an envelope, and mail it out. Well, that costs money. Postage costs money. So we need to keep track of how much each customer uses and charge their account appropriately, right? And some customers we actually front money for. So we have a tab for them, essentially, right? So they start at 0, they use some of it, and then they pay it off. Use it, so it goes negative, right? And then they pay it off. They have a deficit to us, and then we pay it off. Deficit and pay it off. One customer had a deficit of $1 million. Now, this is a problem because we only stored 7 digits of the whole part of the number, right? Now, 1 million without commas is 7 digits. Negative 1 million is 8 digits. So when it did the math and stored the data, it chopped off the negative sign at the beginning. So now, instead of being $1 million in the hole, they were $1 million in the green. Black, whatever. I had to fix that. I had to change 7 digits to 8. And the entire fucking program. That took like a month. PLB is dog shit. Oh my god. Why haven't companies started to switch from COBOL PLB to something modern like C or C++ in the 90s? Yeah, financial stuff cannot have downtime, and it's expensive to replace. Yep, and the risks far outweigh the benefits. Far outweigh. Yeah, there had to be 3 decades for it. They've had 3 decades for it. Yeah, it's cheaper to throw a stupid amount of money at someone to maintain the COBOL than it is to rewrite that in something new and have it break. Because if that code breaks, you go under. That code base is the reason you still have a business. If that breaks, you don't just lose your money if you're a bank. You lose your customers' money. And then the federal government gets involved. And that's never a good thing. When the federal government gets involved and went, hey, what did you do with all these people's money? We have to cover this now because you're FDIC insured. Why did it happen? Why do we have to cover you? And if it comes out that one of the execs pushed really hard to change the code base and didn't really think of the consequences and didn't plan for them, and that's why it broke, he's going to prison. So yeah, the risks far outweigh the benefits. Yeah, it's cheaper. Yeah, far cheaper to maintain than it is to replace. Yeah. Fortunately, where I am, we're not necessarily in that predicament, right? We do have a lot of programs that, like, if they broke, would be fucked. But we do have wiggle room to rewrite a lot of this stuff. And in fact, the new CTO that came in last year wants to push this very hard. So, because of that, I have been given the green light to investigate something else, a new architecture of stuff. Investigate rewriting everything, which I've been doing. Yeah. I told my friend about the Factorio trains, and now they won't stop jailing me about the block. Oops. What's using Go? Here, I'm for this stuff, I'm using Go to do some data conversions, basically. Not that. Again, converting this into read only into this right here. That's what I'm using Go specifically in this project. I also use Go for. Oh, why am I using Go at work for the rewrite? Because I'm familiar with it. That's basically it. I'm the most familiar with Go than other languages. And I am in a position where I get to choose. So I chose. Boss man wanted to do Python, and the reasons for wanting to do Python is like, oh, it's not compiled. That's nice, and it's not statically typed. It's loosely typed, and those are benefits. And I'm like, no, on both of those accounts. I disagree, specifically because Python's interpreted, and specifically because it is loosely typed. I have had those things bite me in the ass at work. Not here necessarily, but at other jobs. They have bitten me in the ass. So, no. Kindly no. Especially the company's probably fucked. Probably. Yeah. No types in banking. Well, there are types. They're just not types that you would think of as types. right? Today's types are integer, float, character string, or whatever, right? That kind of crap. Object. Types back then are numbers, but they're in a text string. Decimal, right? Yeah. Float? No. Fixed point. Fuck you. Fixed point math everywhere. Computational ints for COBOL. Comp 3, I think is one of them we used. Like a packed integer. Like, what the fuck, huh? But no uint. Well, the uint versus int, that's just like, do you want to store the sign or no? Banking doesn't really want floats. No, God, no. Absolutely not. Yeah. In fact, when I was doing the verification to figure out what the fuck went wrong with that accounting software, I was trying to figure out what the hell went wrong, and I was using Go to replay the history, right? So it's a big file, big history file of all the transactions, the dollar amounts that happened, the dollar amount of the transaction, and the ending value of that account, right? So I'm like, I'll put it in float 64. That'll work, right? To verify. Immediately fucking broke. Immediately broke because I was comparing two floats to make sure they were equal. They're never fucking equal when you're adding them. Ever. Ever. So I'm like, oh, that was a mistake. All right. We're going to multiply that number by 3. I'm sorry, by 100. Oh, 1,000. 3 decimal points. And then we're going to store that in an integer. That's what I'm using now. We're using integers, no floats. Oh, yeah. See when in a float is doing it wrong. Oh, God, yeah. Absolutely. Do you know why 36-bit computers were popular? I do not. Anything money, you don't want floats? No. 32-bit floats. What is that? 16,700,216 plus 1 is 216. Oh. Oops. Yeah. But yeah, I immediately found my mistake, and I'm like, you know what? Never mind. I'll just store everything in integers. Because fuck it. The unit is thousandths of a cent. No, tenths of a cent. I'm sorry, tenths of a cent. Thousandths of a dollar. 36 bits could represent 9 digits of BCD. I hate it. I hate it. Or 0.01 plus 0.02 is something like 0.0300000004. Now, binary coded decimal. So you know what hex looks like, right? Hexadecimal. 1, 2, 3, 4, 5, 6, right? That's a hexadecimal number. 1, 2, 3, 4, 5, 6. That hexadecimal number is really that number in decimal, right? BCD is going, no. The number that we want is 1, 2, 3, 4, 5, 6. E, F, D, the letters, those don't exist in BCD. It's literally just 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Oh, it won't let me. Those values are the numbers. So basically, the number is in the nibble, and it rolls over at 9. Or, yeah, it rolls over at 9. So each byte stores two digits. Yeah. Basically storing 1 decimal digit per byte. Binary code decimal for pack BCD per nibble, 4 bits. Yeah. Exactly. Yes, it's less space efficient than integer, than yeah, your standard ints, certainly. But especially back then, it was just easier to work with and print out and all that kind of stuff, right? They didn't really need to do much like binary conversions or whatever, you know. They just like, oh, it's already there, so we're good. In fact, with even on the NES, even though the BCD mode is removed or disabled on the NES, a bunch of games still use that mode. They just manually incrementing it, right? Because it's still easier than the alternative of keeping track of something in hexadecimal and then converting that to decimal for display, right? Yeah. Also, a fun thing you get with money and floats, you can have plus infinite or minus infinite or NaN money. And take up quite some range of possible values in the binary representation. Easy to reason about for programmers who just didn't work in binary very much. Yeah. Yeah, that, and they didn't work in hexadecimal either. They worked in octal, as I found out. So if for something that I would normally look at a hex dump, right? Hexadecimal representation of something, right? This kind of shit. Something I would normally look at hex for. My coworker, who's in his 70s, who's done literally PLB for all of his life, just PLB, for all of his professional career, he instead knows octal. He knows octal, not decimal. No, I mean, not hexadecimal, I'm sorry. He knows octal. So there are places in live code that removes octal 15. That's the CR in the CRLF. That's the carriage return, octal 15. There's other ones that remove the octal representation of like fucking tab and shit. It hurts. It hurts. He'll look at an octal dump instead of a hex dump. So impressive people reading hex like normal numbers. And yes, octal still thing. It is, yeah. The only place I see it commonly used is Unix file permissions. But using like an octal dump of something instead of a hex dump, okay, no, not for me. I'm sorry. Some old hex dump tools still default to octal, mostly for legacy reasons, I believe. Yeah, so on the AIX systems that I still need to get plugged in, honestly, I have them in the other room. I have the AIX boxes, the IBM boxes in the other room, in a rack. They don't have the program hex dump. They have octal dumper, OD. There's a hex flag that you pass to it to be like, no, don't do octal, please, just give me hex, thanks. But you have to pass that flag, otherwise it's default to octal. Hex also fits byte better. A 00 to FF, while octal is octal 0 to octal 377. Yeah, it's weird. Yeah. I don't know octal numbers. I don't. They don't make any fucking sense to me. I don't know. Yeah, let's see. Hex. FF. Octal. Ew. It's disgusting. 17 in octal is F. Yeah, but old systems don't always have 8-bit bytes or 9-bit byte. Octal fits better. No. I mean, I guess, but... but 36 bits is a multiple of 3 bits. With hex or octal, store your numbers in biquaternary. I don't even know what that is, but sure. All right, anyway. Some Japanese... Oh, Jesus. Probably because of all their funny characters that they use over there, right? Make. Okay. It's a number. It's the number system you find in Abacus. Oh. Huh. 1, 2, 3, 4, 5, and then 2. One of, like, this style? Not this style, right? Like a proper one. I assume this is a proper one. I don't know. That. Oh, this isn't even tips and work. Did not load all of it. I don't know. I'll learn more about how stuff was in the fast here as anywhere else. It was fun because I have to go to sleep now. Thank you for stopping by. I appreciate it. Hope to see you again. Past here. How's everything else? Past. But what the fuck is this? Yeah, no worries. You're fine. I can barely read, so it doesn't matter. I can't add, that's for sure. By quinary, I don't know if I say that. Past, not fast. This was in the past here as everything else was fun. Okay. There's a numerical numbering scheme used in many abacuses. Am I saying that right? I don't know. And in some early computers. Oh god, including the Colossus. That thing. All right. In the case of code, comprises both a 2-state bi and 5-state quinary component. The encoding resembles that by used by abacuses with 4 beads for indicating 5 values, either 0 through 4 or from 5 through 9. Another bead indicating which of those ranges, which of the range can ultimately be thought of as a +5. Interesting. IBM 650. Oh, no. Of course there's no higher resolution. The blinking lights. Holy crap. Oh, yeah. 1, 2, and then 5, right? Jesus. Close up of the 6. Okay. Oh, my God. Operation address. Oh, is that in German? Ein, aus. Gangenblauf. Gangablauf. Is that how that said? I don't know. Adressenwall. Address wall? Is that what that is? Did it just say address wall? I love it. I love it. The blinking lights. Yeah. The video I watched mentioned that one reason they used biquinary, I don't know if I'm saying that right, was that it made it easy to spot errors by the wrong number of lights being on in a group. Yeah, all right. I'll post a video about the Japanese. Yeah, I'll watch it later. Yeah, absolutely. Yeah. Yeah. All right. I still didn't fucking reload this, did I? Oh, yes, I did. I reloaded it and went to the first breakpoint, and then that's where we are. Okay, read the data. 94. Where are we at? Pulse. Okay, now 94 and 16. Excuse me. Do command. Instrument. Argument. Pointer instrument 86D0. Okay. That sounds correct. Ish. Oh, there's the bug. There, right there. I scrolled and I'm in fucking data somewhere. Or blank data. Scroll up. Keep going. There it is. Look at the file. Appreciate that. All right. Volume. Clear. Clicker load A. 0. Add that to that. Store it there. Pointer macro. And pointer chan instrument. 2018. Oh, right, because volume is the first one. Right. Oh, 218. Yeah. Might even have had a similar purpose with Ebsidic, preventing punch cards not being strong enough because too many holes. Huh. Yeah, and then yeah, I know what you mean. Yeah. Interesting. As an aside, yeah, I know what Ebsidic is, yeah. As an aside, do you know that OpenSSL still supports Ebsidic? Did you know that? That current OpenSSL code still supports Ebsidic. Because fuck you. Punch card, that's in the image. Yeah. That's right. Yeah, OpenSSL can go to hell. SBCL? What the hell is SBCL? Alright, anyway. Copy macro. Compared to FF is not an FF. Index offset. Pointer data macro. Do I have that here? Nope. A4E9 looks right. Looks right. Steel Bank Common Lisp. Got it. Nope, not that one. Up here. Running and offset. Loop. Release. Length. 0F. Pointer to the data. RTS. And then we do the same thing for the others. And duty. JSR. Oh, yeah, because it needs to... Yep. And then double increment channel. So this... Load Y, load A, add carry, pointer channel, plus... Is that correct? Pointer channel plus 0 at Y. Read offset. Yes. So it's currently 0, right? That's going to be load Y, load A, add carry. Wait a minute. Add carry 0. I didn't clear the carry. Shit. So let's reload that. And it scrolled down again, bastard. Right there and right there. Okay. There we go. That's better. So I see also and hate it. UTF Absidic. Alright, pointer channel, get pointer to instrument, right? Alright, frame list and load up all this shit. Offset noise stuff. Not noise stuff, store. But... Oh, right, this is the actual note now. Because now we load a note. We loaded a note. And then RTS. And pulse B to the same shit. Okay, this should actually work now. In theory. It didn't crash like it did before. Nothing's being written. Nothing's being written. What the hell is that? All of it's 0. Nothing's in the buffers. Why is nothing in the buffers? Why does this keep getting red? And it's still getting triggered. A is 0. Why is A 0? Why am I in clear buffers? Okay. Oh wait, hang on. Now they're written. They're written once. Okay. Something screwy is happening here. Right buffers. Clear buffers. Right buffers. Clear buffers. Why? That's the end of... Yeah. Right, clear. Previous frame. Clear buffers. What the fuck was that? And then the end of processing the sound. What the fuck? Missing code to set the ready flag when you write the buffer, maybe. I don't think so, because the write buffer's code is actually triggering. I'm making a NES music sequencer, not a sequencer, but just an audio engine. Welcome, by the way, Casio. An audio engine to play sound or music. At least that's the idea. Not exactly working right now, but you know. Oh, this one actually doesn't. Hang on. Wait a minute. This one doesn't. Load Y. Ready. Load A. 1. Store that into pointer buffer at Y. It's the halt that does it. Process channel. Okay. Yeah, I don't actually do it anymore. Okay, good catch. 1087. Thank you. I was actually just looking for this code too. I was just looking for this code because I want to. Let me do that. And do that as well. Oops. Yank. Paste. Paste. Do I... Hang on. Oh, audio is enabled. Okay. They're never set as ready. Ever. Did I... Hang on, I didn't make... Reload. They're never being set as ready. Why? That's clears, okay. Duty vol. Ready. I added the ready there. I didn't add it here. Thank you for the follow, by the way. Appreciate that. Okay. Wait, no, I had it there already. And that's it. It's noise. Here's the note stuff. The notes never did it. The notes never said ready. There we go. I heard something for a second. I thought I did I? Was I hallucinating that? It does for like one note. Turn that way up. Bring. Huh? Bring. What? You can hear that, right? Nothing surprised racist town voted racist. Well, there you go. So something's clearly wrong. Triangle shit. Can I? No. That breakpoints don't know, apparently. Advanced. Equalizer. No, advanced. No. I can't just, like, disable a channel. There we go. Triangle. No. It was the triangle channel doing some weird shit. Okay. Debug. Let's get a watch window. And let's add, what are we adding? We're adding, pulse a buffer. How big is that going to be, though? Oh, that's just 4. All these are going to be 4. Comma 4. Pulse B buffer, comma 4. Okay, if I can spell buffer correctly. Capitals and all. F2. Oh, okay. Fucking triangle buffer, comma 4. And noise buffer, comma 4. I am seeing stuff being written to all of them. Are they all being written, like... Hang on. I missed one of them. Did it again. What? It's all the same. That ain't right. That ain't right. Why are they all the same? Two C8. They are all identical. Which is wrong. Do I not load up the buffers correctly? Pulse A, pulse B. Not trying to read the next row. Okay, well, I want to read the next row. Okay. We're here. Go to order. That's equal. Okay, pulse A. 20C, pointer channel. 20C. Okay, let's have a look at that in the memory viewer. Pulse A state. Okay. And the buffer, 02C8. Right there. Okay. Load that, put it at 0. Process channel. What is this one? Load Y7, load A0. I need to put comments on those. Process channel. Check for weight. That. That's fine. Paste that one. And then I should have put this one on the oops. And the copy buffer when I did that, when I copy paste that around. Am I doing those as well? Am I not doing this too? Maybe, I don't know. All right, put that there. Oh, no. That, no. There it goes. Okay, Jesus. These aren't actually used anymore, I don't think. The channel, these ones here. Okay, another ready again. Okay. Reload. Okay. I stepped over it. God damn it. I stepped in this one. B doesn't do anything, actually, on this menu. And mine, yes, it does. Ready. Okay. Wait. We reset ready on it. Fine. Instrument structure. Yeah. Current frame. Read offset. command. Right. And this loads up the command. Just load instrument. Loads up the instrument, rather. Double increment. Okay, and then it goes to the next process here. Channel ID compare 3, branch not equal. Not noise stuff. Load the data. Load Y. Oh, we can ignore that. ASL A. Transfer A. To X. Note. Channel buffer timer low. 2CE. Pulse speed buffer. Okay. 7F. 7F? I mean, okay. Oh, 27F. That. All right. Yeah. F1. F1. Fuck me. All right. Does it set the volume on this actually? Rather, what is No, that's instrument. That's instrument, not volume. That's instrument. The instrument's already loaded. Buffer ready. Yeah. So instrument maker is running to 1. RTS. Okay, now this one shouldn't have the same output because F2. It's close, but not quite. Different instrument though. Okay. Process channel. We're going to put a breakpoint here because we're going to load up the instrument. All right. Pointer channel. Channel construct. Okay. Frameless stuff. Read the data. E64D. Sure. 90. Nope. 20. And 04. Okay. No, 27. Wait a minute. Huh? Because that is not the instrument that I'm reading. All right, I skipped over the instrument stuff. It's not minus. So restart the note. Reset, restart note. Hold Y button X. What the fuck? I don't know what the fuck it's doing, but it's wrong, whatever it is. I don't know where it's getting button X from. Let me start up stuff again. Could be. All right, where was it? Where was that? Do command. Yep, that's exactly what it was. Loads up 0 instead of whatever it needed. Or loads of 8, excuse me, instead of whatever it needed. Jesus. Thank you for the follow. Appreciate that. Follows, excuse me. Thank you. Go over here, reload that. Okay. Sound process is going to be the instrument. Why did I hear a beep between the 2 breakpoints? Why? That tells me that that wasn't even... Wait, hang on. This is sound process, right? Never mind. Wait a minute. Excuse me. Jim Muggy, you have a good night. Thank you for being here. Appreciate it as always. The fuck? Kind of better, but also not. Also very much not. Huh? Alright, what the fuck is it doing? Channel ID 0. Process the channel. Pointer to instrument, frame list, bunch of pointers, breaking them out. Data, 14. Doesn't matter what that is, because it's going to be not a command probably. 4. Store that there. Load ID, compare to 3. Comparison ID equal. Not note stuff. Load the data. Load Y channel ID. Okay, who cares about that? Transfer A to X. There's that 7F. 027F. Load Y. Timer high. 02. There's that 02. All right. That buffer's ready. Resets all the macros to running. Although I probably shouldn't with that. Maybe we should have like a disable bit on that. Check the disable bit. See if what addressing modes does bit have? I don't want that window. I want this window. Yep. Oh boy. Not any of the ones I want. Okay, cool. Pulse B. These almost never line up. Why? What? I don't think that weight's working correct. That offset resetting code is the LDA is 0 for the comment. In a comment. What do you mean the offset resetting code? Location. The process instrument, that right there. 180. Ready. Let's press. Oh, that's all. Nope. The knob is only there so I can get that comment on the line I want. That's all that's for. Literally for the comment, nothing else. Oh my god. Thank you for the follow, by the way. Appreciate that. The bit that starts macros running and resets that are offset. Starts macros running. I see. I know what you're saying. Okay. So not doing the instrument, but like, hey, we've got a note. Reset the macros. That bit. This stuff. Nop again, because I want the comment here. What is this? Where am I? Where the hell am I? These are all wrong now. That's cool. Delete that. If I shouldn't do that, need to disable something. Sound process, pulse A, process channel. No, let's go up to back. Let's go up to there. I hate that beep at the beginning. Okay. Okay. So now we're loading up the note, not the instrument anymore. Instrument should be loaded. Frame list. Offset stuff. Data 1B. All right, okay, so now we're in reset. There is the reset code. Good. 1B. Compare that to 3. Not equal. Not noise stuff. Okay, 1B is ignored. 28. Noise table. 2F7. 7F, excuse me. Ready. Okay. Do I need all those like that? Do instrument. Clear out the ready bit. Did that? Doesn't even check it. Doesn't even fucking check it. Let me see. It's that. Last note. Load A. No, nothing. Okay. Load macro. Stored a FF. I don't like that. What? The hell? Something's going wrong here. Tempe shouldn't be FF, I don't think. Hello, how you doing? Giuliano? Am I saying that? Saying that right? Marde? Welcome. Because I being a pro can't understand shit. You look like a magician to me. It's not that bad, but welcome. How you doing? And Catador? Am I saying that right? Hello? Yes, a NES sound driver. Yep. Lalavi? Lalevo. I can't read, I'm sorry. It's pronounced like Julian. Okay. Got it. With a no. Giuliano. Started the second try. No worries. I don't remember what it was, but sure. I don't remember how I said it, but sure. So yeah, currently it doesn't work. This right here. I'm trying to figure out why. Why no work? So apparently it's like writing. Ooh, it's something different there. Oh my god, the triangle's got something different in it. But it's not doing stuff right. Now, you can hear it too. You want to hear how wrong it sounds? It ain't supposed to sound like that. That's wrong. That's bad. It's wrong. C58D. The count was LDA 0, but the code doesn't. C58D. C58D? That's data. Glad you're honest. Someone looks so intimidating. It looks intimidating. That's about it. I only ever coded pretty high levels like Python. This is a little lower than Python. Assembly is just very verbose. That's all it really is. It's just very, very verbose. Yeah, in order to work with like an object, like in order to access a field in an object, I need to like load up the offset to that field and then make sure I have a pointer to that object and then, or make sure I have a pointer to that object and then load the offset and then load the data at that offset from that pointer. I said C whenever I started the margin. Probably A? 8, I mean. 8, 5, 8D. Nope. You must have heard something. I don't know where you're reading. Now, is all your data after all your code? The audio data, yes. All the audio data comes after the code because it's included at the bottom of the file. 8. That's all the code right there, which actually isn't that much. And then here's all the audio data. That's all the music data right there. So that. Nothing's on here. until I get to the mirror. Oh, you know what? You probably did. See if I see, because I forgot. NROM, half an NROM actually. Wait, what the fuck? Hang on. Note table. Oh, this is the actual audio engine. What the fuck? Hang on. Yeah, God damn it. C580. This stuff. This. Reset all instrument macros offset to 0. LDA 0. What? What? That's not in process instrument, right? That's in process channel. Yeah, that's somewhere else. This guy. When did that happen? How did you catch that? Didn't fix anything, but you know. What they okay, so it should sound. Well, actually, I can just play it from here. Like this. I'm sorry, like this. Yeah. That's what it should sound like. That's not what it sounds like. Was that loud, by the way? I feel like that was a little loud. At the very least, like this, because this is just the 2 pulse channels. Or like this, because this is just the first pulse channel. Right? If I don't write the other channels, or whatever, the other buffers. So, that's wrong. Very wrong. Oh yeah, this is an audio engine for to be able to use in other NES ROMs, right? That's the idea anyway. I've got 4 songs here. So title screen, level 2 level musics, and a game over. All right, game over's this one. Not as fast as it could be, yeah. I didn't write this music, by the way. I commissioned someone for this, but thank you for the file. I appreciate that. First level music. Yeah, I do a lot of NES stuff here. I do some. I write some stuff, and I also reverse engineer a lot of stuff. So my current reverse engineering project is this thing right here. It's a Famicom. This isn't the Famicom. I'm sorry. This is the Study Box, which is a Famicom device. It's a tape device. It's got a tape drive on it. This is different tape data than your data recorder stuff. This has recorded audio on one channel and data on the other channel. And it's not like assembly data. It's a scripting language crap. That's interpreted in VM on this thing. Those are for stuff like teaching English and stuff, English and math and science and crap to Japanese kids. Yeah. I only virtually engineered a tiny bit of Kirby's Adventure because I realized HAL Labs backported their SNES sprite engine to use in the game. Really? Huh. That's interesting. I wouldn't think you'd be able to backport sprite engine from the SNES to the NES. I guess not that different, right? Oh. But yeah, this stuff is weird. This stuff is really weird. Every sprite runs a script. It's interpreted bytecode. Oh. Things like zero val, set X position. Okay. A lot of versions of a custom file format we use at work. Then we got a writer working. Well, got something else I reverse engineered, which was work related actually. It's right here. Proprietary font, Xerox font. I reverse engineered it because it was there was a pie chart font that I wanted. I wanted the pie charts. I eventually got the data out of it that I wanted, but so these are this is a font format that we actually still use at work. It was created. This format was created in 1978-ish. 78, 79, right around there, for use with the first laser printers. Xerox invented the laser printer, and this was the font format they used for that first laser printer. It's a terrible format on modern standards. It's a bitmap format that's a specific size and crap, and it's crap. Only supports like 600 DPI, I think. I don't know. Letters are all kind of rotate a little bit. But, yeah. Worked on this for a little while. Figuring that out. Because I saw... So at work we have these binders of font samples, right? Which makes sense for a printing company, right? It makes sense. I was paging through one of them one day because I was curious. And I flipped the page and all of a sudden I see slices of a pie chart. I'm like, what the fuck is this? Pie chart? No, stop it. What? Slash Life, how you doing? So in order to like build up a pie chart, you just stack these slices on top of each other. And there's like a bunch of different freaking format styles rather. A bunch of different styles for it. So I can find them real quick. Hang on. Xerox fonts. That's not what I wanted. Where the fuck did I... Hang on. What? No, that's not it. Where did I put this? Oh, God, where did I put this? Uh-oh. I'm not going to be able to find it now. Gonna topple over the P. Yeah, that's fine. There they are. There they are. Oh, that's disgusting. Hang on. Do I have ones that aren't that disgusting color? Ignore the pink crap. But yeah, so they're, you know, different formats. They're different styles, right? For a bunch of this stuff, there's just... Weep. Seven, which one's this? These aren't the fixed ones, though. Where the hell are the fixed ones? Command output. Where the fuck? Forward. No. I need to, like, fix this directory. Simple fonts, text font, output. Yeah, no, not that. Archives? Nope. R. Well, there's some of them. There's these again. There's that. Okay, date modified. How about that? X font. 2004? No. What? Decoding. There they are. That's what I want to think. Images. Nope, not that one. Oh my god. Oh my god. This isn't what I wanted, I don't think. X for Xerox. This isn't even aligned correctly, is it? Yeah, those aren't aligned correctly. What the hell? Those ones are aligned correctly. All right. Do I really not have the fucking pie chart one somewhere? Like decoded and whatnot? I could have swore I did, but I can't find it now. What's this? Oh! Well, there's some of that. This is the, I was, trying to figure out orientation and stuff for some of this. I got it wrong on this one. I didn't rotate it correctly. Oops. Eventually, though, I did get it all working where I got it, you know, printed out. This is the bold and then normal. Oh. I don't have a sample with like a compiled pie chart though. I wish I did, but yeah, these are individual characters. Individual characters. That's executable. Oh boy. Oh boy. Did I? Did I put it here? There it is. Xerox fonts. Got the little bit of write-up. Oh, where the hell is this code in my system here? Oh, God. Oh, it's here. Oh, that's disgusting. Ew. 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 There's another sample of it. Okay. Anyway. But yeah, so I reverse engineered that over a few days. A few weeks, excuse me. Because I wanted the bitmap font and all that. Well, most of the other stuff I reverse engineer is all what's it? NES related, NES or Famicom. I've also got another project over here that's in pieces right now, and I need to get back to eventually. That's the titler, which is neat. But anyway. That's cool. Neat little device, I think. This I'm gonna have to pick up next time, I think, which is gonna be a little while. I mentioned it earlier, but I don't think any of you are here for that. Next 2 weeks, I'm gonna be off. I got crap to do. So for 2 weeks, I won't have stream. It's gonna be a while. It's gonna be a while until the next one. Yeah, the 28th will be my next stream. A while from now. Yeah, I've got some weddings to go to. I've got a birthday thing to be at. Yeah. Anyway. Let's go see who's streaming, who we can say hi to. Because I need to go get some real food instead of just munching on this, honestly. I don't know. Just fucking rant on Discord. I don't know. Do what I do. What is this? Looking for someone to raid? Check out the new raid browser. Okay. What is this? Does this show, like... Huh. This is interesting. Oh, okay. Huh. I haven't seen this before. I'm going to have a look at some of these. Let's see if this works. Read manga? Watch anime? Unbelievable. Unbelievable. No. Retro turn-based tactical war game. Pico 8. Can I... What is this? Oh. Huh. Oh! I remember this guy. I'm going to turn off the audio for you so you can't hear it. Yeah, I think we're going to say this guy. Let's see, start rate. Let's see how this works over here. Whoa! Okay, neat. Yeah, come with me to say hi. I'd really appreciate it. I'm going to be away for a while. Join Discord if you haven't already. I'll be on there for all of it. Yeah, I made some progress tonight. Maybe not as much as I wanted to, but yeah, whatever. Thank you for being here. I hope to see you next time. And yeah, you guys have a good night. Bye.